Yeah, that's not always great. How to measure them nationwide, I'm not really a statistician. Like I can't, like, I could probably do a better job at that, honestly. Like, I'm trying to do fewer things now, and I'm trying to not overcommit myself. I think also when you're interested in these topics, like, I don't know how many
All right. Good morning, everyone. With us today is Justin Castilla. He's a senior developer advocate at Redis, and he has produced several online courses for the Redis Academy. And today he's here with us to tell us about how to monitor air quality with Python and the Raspberry Pi. As always, you can ask questions via Slido in the Risotto room. And yeah, enjoy.
Oh. Thank you very much. Thank you, PyCon Italia, for having me. This is an honor and a great excuse to come to beautiful Florence. Fun little story. It actually has to do with air quality. I was late on my plane. I got here very early Thursday morning, and I didn't get my clothing and my luggage until very late last night. So I was actually worried that I would affect the air quality with my clothing. But I'm fresh, I'm clean, so it's not my fault. So that background's kind of a bummer, right? It's kind of gross. September 2020, it was known as the Red Day in San Francisco. I was living in San Francisco at that time. And the entire day was, The entire day was red, dark red. Birds wouldn't wake up. There was no wind. It was really, really freaking creepy. And it was because of the wildfires that were happening all upon the west coast of the United States. It was just creating horrible air quality. People were having all sorts of problems. And this is one of the days that we saw outside the window where it just did not get light. And this happened throughout West Coast for many, many days, for many, many years. It's kind of subsided because we've kind of ran out of forests to burn, which is a really, really sad thing. But if you do a quick Google, we've lost cities, Paradise, California, the entire city was just razed. Mismanagement, climate change, all kinds of fingers are pointed. Climate change being a big one. But it was really sad. Let me make it more sad with some sad introductory stats for all the wildfires that we had. 41,580 square kilometers of land just gone, just razed to the ground. 58,258 individual fires occurred within California within that year. 0.7 kilometers square average per fire. So it wasn't just like a small campsite fire that got big and then just died out quickly. No, these are big ones on average. 13,887 buildings destroyed. That's not just cabins or homes in the woods. That's gas stations. That's chemical warehouses. That's things that's throwing up really bad toxins in the air. Financially, $19.8 billion USD lost. And that's within California, Oregon, Washington, and then all the untold financial damage caused from a loss of commerce within those areas. And then we're estimating 1,200 to 3,000 excess deaths from exposure to wildfire smoke. That's not the fires. Fires killed people definitely, but the effects of smoke were almost a little bit more deadly. Also, we learned about fire tornadoes. You never see one. I mean, I never see one. I've never seen one, but I saw it on the news. And it scared the crap out of me. These are just two, but there are multiple. It's when you have super hot air because of the weather, plus the wind, plus the fires. It just sucks up all the oxygen and it creates these really small, localized squalls that will create these. So, wildfire smoke, how does it affect us? Well, it causes eye and respiratory tract irritation. My lungs were horrible. My voice was deep. I sounded very sexy, but not in a good way. Reduced lung function. You can't go outside. You can't run. I mean, I don't really run, but I couldn't do outdoor exercises. I couldn't do chores. I couldn't do my woodworking, things like that. Exacerbation of asthma and heart failure. So those that have pulmonary disease or asthma or any kind of long-lasting condition that will affect them, smoke's just going to make it worse. So how do we actually measure wildfire smoke? It first starts off at PM 2.5. That's particulate matter 2.5 micrometers and smaller. So that's actual particulates of the smoke, the wood that's burning, the houses that are burning, everything that's burning, it's in little tiny pieces of matter in the air. 2.5 is small enough to pass through to the deepest part of the lungs and into the bloodstream. Anything bigger will just stay in the lungs or just be kicked out through your cilia. But 2.5 and smaller is the bad stuff. That's what goes into your blood. AQI is a computed value based off 2.5 to convey the health risks. 2.5, like the particulates, might not be bad. So we're right in front of a street, a thoroughfare. We're breathing in higher particulates. Those aren't good, but they're not as bad as, say, chemical particulates from a chemical factory. I don't know, do you have like any kind of like an air quality index mapping system in Italy? You like colors? Yeah. Americans don't do numbers very well, so we like colors. Color, easy. Green is good. Don't worry, green is right now. I've been checking it ever since I got here. We've had good air quality. And then it goes progressively down to scarier colors. This is maroon, and that's really, really bad. When the red days happened, we were in purple. And that was really, really just very, very scary. That was worrisome. And then we had maroon happen a couple times overnight when we didn't even know.
That's pretty cool.
Oh. So I actually created something. I put some stuff together to actually create a localized air sensor. Because I was looking at maps that were provided to us either by our local county, our local government, or just weather stations. But they were never fast enough. They weren't real time. And they didn't reflect my local area. So I was next to a lake. I was next to a highway. And I was next to the San Francisco Bay. So all those things blew air around, but also retained air. So I never knew what the air quality was inside my little hyperlocal area. So this little guy, it's about $15 USD. It's a particulate matter sensor. And it uses lasers, which is awesome. So it has a little tiny, tiny fan. And it sucks in air, shoots that air with a laser, and it counts the amount of diffusion from the pure laser to the laser that went through the air. And it could determine the actual amount of particulates that are through the air. And not just the size, but, not just the count, but the different sizes too. So it could tell me values below 2.5, values above 2.5. It is important to note that you can't actually tell what is in the air. There is another sensor that they're releasing that will use machine learning to tell me what kind of chemical compounds are in the air, which is really exciting, and I'm going to add it to this as soon as I can get my hands on it. But for now, this one just tells me how much stuff is in the air. And it computes it out to bytes. So I added it to a Raspberry Pi initially, but then I realized the Raspberry Pi was a little overkill because I didn't need an operating system to read the data. I needed something even smaller, and I could get away with something smaller. Because that way, it can make it cheaper, it can make it smaller, and it would consume less energy. And we can't find Raspberry Pis anymore. So, Raspberry Pico W's, though, are pretty great. Just some of those stats right there. It can run MicroPython, it can run CircuitPython, C++. I'm trying to get it to run JavaScript, because I think that they need to learn how to use this stuff too. But it's not very easy, of course. It has wireless. It does have Bluetooth. It's going to have an update, so you can actually run Bluetooth on it. 264 kilobytes of RAM. It's pretty fast. It's pretty amazing. $6 USD. That's even better. And I bought it in bulk. I bought 20 of these, so the price dropped down. And here it is right here. I 3D printed a little box. This is a big box because I'm not a very good physical designer of objects, but I can make a box. The air sensor breathes in through here, spits out through this little line, and the Pico W is connected via wires in here, and it's running right now off my laptop. There's one in the back of the room that's running off a power bank. I have one running in my room. I learned this the hard way. We take out the card power dies. It's running off of 3 AA batteries. I have one in a veranda, and I have one just sitting on my table in my room, so we can watch that. So these run on very low power, but it's still connected to the wireless, and it's still running the sensor, which is pretty cool. So I'm sending all this data to Redis. Those are my overlords. Open source, NoSQL database. Anybody catch Paul Ford's talk yesterday? It was on migrating to NoSQL. It was a really good talk. He's a dev advocate for MongoDB. Fantastic service. We both swim in the same circles. He's a tuna, I'm a salmon. You want us on the same sushi plate? Like, we're not competitors, we love each other. We run in memory, not on hard drives, so it makes us very, 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 very fast. And we can store key value pairs, so strings, numbers, sets, sorted sets, time series, which I'm going to be using here. Store JSON, query that JSON, store streams, probabilistic data structures, Bloom filters, things like that. It's pretty cool. Also created by Salvatore Sanfilippo, also known as Antires. He's a huge contributor to open source. He's a creator and primary developer of Redis, and he might be here. I don't see him. OK. He's kind of like a real big guy in my industry. Go Antires. All right, so some actual code. This is running on, this is MicroPython. Do you see a huge difference? No, you don't. It's not very huge. This is running on the PicoW, and I can just use Visual Code to run this with a little extension that uploads it to the machine, and I can see it running. So here I am connecting to wireless, and here I am connecting to Redis. That's really all I have to do. The great thing is there is a library for Redis that you can run for the Pico. Pico does require specific hardware libraries and specific libraries just because it's very, very small. But more often than not, it's not too hard to create. So here I'm actually reading the sensor. So raw reading equals sensor.read. That's all it takes. It'll give me a large object of different readings. The PM25, which is what I'm looking for, PM21, PM2, PM1.5, and anything larger. So I just go through all that. I pull out what I actually want. Raw reading PMUG, that's micrograms, per M3, so that's cubic meter. I'm looking for the 2.5, that's the PM2.5. And then I run it through an algorithm that converts that to an AQI. That's the actual health index. Air quality index that we actually look at, we can figure out. Also, the PicoW unit comes with a temperature sensor for free. So why not just include that as well, in case you want to know the temperature. And then right here, results equals redis.xadd. Now that's going to be adding this reading to a stream. Now I'm going to be adding a target, which is, I'm naming all my different sensor units. Otherwise, there's no point in, I'm going to call this podium front or risotto podium. Back there, I'm going to call it risotto rear because it's important to kind of know where the location is of all these sensors. I'm also including in the stream PM2.5 value, the AQI value, and the temperature value. And I'll talk a little bit about streams in the next slide. On the right, you see just some little housekeeping code. I want to know which sensors are live. So every 5 minutes, they're going to set a string that says, hey, I'm alive. And right here where it says redis.set, see that I'm creating a TTL, that first argument here. Over there. That's, I'm creating a string right there, TTL colon, and then the sensor location. So every 5 minutes, this sensor right here is pinging to Redis. It's creating a string, TTL. And for this one, it'd be risotto colon podium. And TTL means time to live. So after 5 minutes, this string is going to die. So that way, I can actually see what units are active out in the field at any given time. OK, so a stream, the data structure real quick, is you can think of as an ordered list of objects. So an ordered list of an entity that contains any amount of key values. There's no schema to it. You don't have to keep it that way. We have target, PM25, AQI, and temp on every single stream. Am I cutting out? Yes. Yeah, OK. Cool. I'll turn this off too so we don't. argue.
Okay. So each stream or entry ID that you see right here is going to have, am I still talking? Can you still hear me? Okay. Each of these entries is going to have a value from, say, this one that is named office. So office has a PM25 of 4, an AQI of 16, a temperature of 67.75. Now the stream keeps everything in order. And you can see right here, the stream entry ID. What does that look like? Timestamp, yeah. So everything is created by default with a timestamp. And so I let Redis create that timestamp. So this has a chronological storage of every event within that stream. So if I can do it with one of these units, I can do it with as many units as I want. And it's not really that hard. One interesting thing to note is whenever you see a entry ID with this, a number starting with 1 instead of 0 at the end, that's a sequence number. So that means that there was a collision at the exact same time. Very rare, but when two entries with the exact same timestamp happen at the same time, it'll just add a sequence number. So that's why you see those 1s or those 2s at the end. So once I have that stream, that's just my huge, large queue of information. Afterwards, I can start parsing it out and turning it into different fun, neat things. So I can turn it into a time series. A time series is just a long ordered list of a timestamp and a value. Somewhat similar to a stream, but a time series, you can slice it around, you can play with the ranges, you can do some interesting information, do some aggregations and averages and whatnot. I can store everything in JSON. I can use it to trigger notifications, SMS, things like that. And I can also query that JSON if I want to find date ranges where the average air quality was bad or the average air quality was good. So I can compare that to other factors such as it was raining or it was the weekend or everybody went to a concert and left the city or something like that. When Burning Man happens in San Francisco, it's wonderful. The air quality is so much better. So creating a time series is just built into Redis. So what I did, and this will all make sense why I'm creating time series, I'm reading from the stream. And I'm reading a stream entry ID, which if I just want to read the most recent one, I'll give it a $sign. Otherwise, I'll pass it an actual timestamp. And you'll notice that I'm calling block 50,000. So I'm going to just sit there. This is a looping script that just sit there and wait up to 50 seconds and wait for a new reading. And as soon as that reading comes up, it will execute the rest of the code. So I'm pulling data out of the result. And then down here at the bottom, I'm creating 3 different time series. Similar to what Paul said with MongoDB, where we're in memory and we're not constrained by SQL, we can actually use data a lot. We can have duplicates. We can have large amounts of small pieces of data. So I'm creating 3 time series. And it's just Redis, TS, and then add. The first argument is going to be the name of my time series. So the TS key prefix, say for this machine, will be, again, Risotto : podium. The naming convention for Redis is to separate everything with colons. So PyCon : Italia : 2023 : Risotto : Justin to get my location or something like that. So I'm creating 3 time series. And once I have that time series, I can offer it up to any kind of visualization software. So Grafana was the first one I picked, and so I stuck with that. You can do many different ones. It's not a problem. And I'm using the Simple JSON plugin, which just sends requests for a time frame to and from, and it says, give me this data. And this is just a continuation. I, of course, have this on GitHub that I'll be able to share with you. It gives you instructions on how to acquire the hardware, how to set this all up. There's 3 different scripts that you run, one on the Pico, one to consume the stream and turn it into a time series, and then one to actually provide an API to Grafana. And this is what you get. So this was my spare bedroom between 1435 and 1545. It is interesting, the air quality on average lowered or got better. It's kind of hard to, but of course the air quality was really good to begin with. So I had every room in my house powering one of these, and it was really interesting from a personal standpoint. When I cooked in my kitchen, all the air was being sucked out of there and into the sunroom. So I was cooking and I was watching the air quality, and it wasn't really changing, but my sunroom was going really bad. I was like, well, I'm not a bad cook. What's going on? And it was just, you know, all the air, the cooking vapors and the oils and things like that would amass in the sunroom. So the sunroom had a higher air quality index. So it was less quality air, and it would stay there a lot longer. And I would also use this to create some JSON. Here I am doing that xread command again, pulling out all the values, and then right there, that's how I set JSON. I'm setting JSON into Redis. Redis is not just key value, now it's JSON. You can parse through JSON, edit, update, things like that, and then query through it. And then I can do bonus SMS notifications. So this is just an extra thing. Here I'm creating an array of 12 empty values. If I have those empty values add up to a larger sum, that means that after 12 readings, which is a minute, if I have bad air throughout a minute, then I should get notified. Otherwise, I get texted every 5 seconds. And I learned that the hard way. And yeah, I just used Twilio. You can use any other service. This is also an excellent opportunity for you to use an emailing service, or even cooler, you can trigger a relay, which is not hard. You might shock yourself a little bit in the development mode, but it's not that very painful. You get used to it. Yeah, you can turn on fans, you can turn on windows, air purifiers, you can close windows, you can open vents, whatever you want. You can also share this data externally to Purple Air, which is a website that amasses crowdsourced data values. You can send notifications to your Alexa unit to actually speak into a unit, you know, hello, your room is bad. Get out of your room, the air quality is bad. And yeah, email notifications, and then I'm working on a little heat map of my actual house to show how the air quality changes throughout the day. The sun bakes one side of the house, things are released, the sun cools, and you know, sun goes into the other side of the house. How does the air quality change? I really want to find that out. So, the repository is right here. It's under Redis-developer, lots of fun projects with Redis. It gives you the Pico code, the consumer services code, the API code, STL files for printing, instructions on how to put this all together, and some data sources that I used to actually gather all this information. And this is open source, of course, so please build it, improve it. I would love to get some feedback on this. And if you are curious about Redis, I do teach courses at the Redis University. If you have searched YouTube on Redis, you've probably seen my face as a thumbnail, and we're always on Discord chatting it up. So, yeah, thank you very much, and breathe easy. And one more thing, sorry. Here's the actual air quality. Let's check out right here. So this is the hotel. Wait, no, that's the hotel room. Don't look at that. It's stinky in there. Let's look at the podium. There we go. Not bad at all. So the top, let's see, around right here is at 54, so I might have been talking really closely to the unit. And then we look into, looks like the back unit died because my power bank probably went out. But if we look at, say, the hotel room, the air quality is pretty good. And then we look at the veranda. It's a little bit higher just because it's in front of that street that's off-putting gases and tire dust. So, cool. Questions?
Thanks, Justin. Maybe you can go back to the slide with the QR code for a second, because I think some people here in the front missed it. I just noticed that. So just give me a little nod if you're done, and we can go back to the stats again.
It says that the QR code campaign has been disabled for some reason. Your QR code scanner is
Okay. I'll pop this link to, it's just a GitHub link. I'll throw it out in the Discord. Yeah. Awesome. Thank you. Thank you for calling that out.
All right, so then we can start with the questions. The first question is, if the connectivity drops, do you lose the result, or do you cache them somewhere and send them later to the Redis?
It's a good question. So if the connectivity of the actual unit drops, it is lost. So I could create like a local queue, which is not a problem. The only problem is it can't exceed the space that is inside the Pico unit, because the Pico unit is small, 264 RAM. So I could work on storing that into the actual storage of the unit, the actual like memory, but that's just further work. So yes, you can create a queue to wait and for reconnectivity up, but for now, this just spits everything live to the Redis.
Or is that not possible? For Poland? Do you know, is that the word? Poland? Yeah.
Oh, pollen. Yes. Unfortunately not, because it only looks at size of things. But there is a new sensor that is looking at the actual chemical makeup of things. So this only tells me the particulate matter. So it will still warn you if there's a high amount of pollen in the air, which still would help. But yeah, I can't tell you specifically what's going on. There's more better and higher quality sensors that are out there that are more expensive that I could use, but this is for quick, cheap dispersal.
And did you see any correlation between the inside and outside measurements with regard to accuracy and maybe similar developments?
Yeah, so some of these have their own little quirks. Some of them tend to be a little bit higher than normal. So what I like to do is I'll have them in the same room within like a little cluster. And for each unit, I'll tune them to have the exact same baseline. When you have them on the outside, it is very volatile because the smallest puff of wind will change the air quality instantly. Sometimes you will get pockets of bad air. Sometimes you'll get pockets of good air. Inside the house, it tends to stay the same, but you can definitely tell when, say, like your HVAC kicks on, and if you have air conditioning or a heater turn on, you can see when it's on, the air quality changes, and when it turns off, the air quality changes. And if you have a fire in the house or a wood stove, even a gas fire, it definitely reflects. You can see that.
All right. Did you face any challenges setting up Redis on MicroPython, or was it the special Redis library for MicroPython?
That's a great question. I am so happy that there is a company called Pimoroni, P-I-M-O-R-O-N-I, Pimoroni, based out of Nottingham, England. And they wrote code for the Raspberry Pico W for Redis, which was fantastic. So I grabbed that, thanked him profusely, ordered many units from them, and I just slapped it into the exact same Pico W as this code. And so it already exists. Could it be better? Yes, but it's great work on their part for not working for Redis. So we're probably going to fork it and work on it and add some more things eventually. But for my use case of just adding it to the stream, that's all I wanted to do. I just wanted to get that data up there, then I can play with it later.
Awesome. Do you guys have any more questions? If so, we have some more time to discuss any additional questions. You can also raise your hand if you want to.
The driver code for the actual sensor is also freely available, and it's for the Raspberry Pi and the Raspberry Pi Pico W. So this one I selected because it was the easiest to use and the easiest to acquire too. So you can build this anywhere.
One question. So you said that one of your Raspberry Pis is running on the batteries, so AAA, those AAAs. How long does it last?
Well, I'm using a power bank that I've had for like 5 years, so that's my bad. I should have used better batteries. The ones that are in my room right now, those are running on batteries that are fresh, that I charged overnight. Those will run for 8 hours, 8 to 10 hours. And then if you have it running on just wall power, 5 volts, 2.1 amps, you know, the standard iPhone or modern Android charger, that's perfectly adequate. So. And you can run this theoretically on a solar charger if you had that set up. You just have to supply 5 volts 2.1 amps.
Question, what's the sampling frequency of the sensor?
Yeah, so you can do down to half or quarter seconds. I chose 5 seconds. Realistically, if I was to create like permanent fixtures, I wouldn't do 5 seconds. 5 seconds is for the wow factor of the room. I would do more 10 minutes, just because greater changes aren't going to happen every 5 seconds. 10 minutes is when I actually want to go.
Time average, though, sampling and average and just record one single.
Yeah. Yeah, so you can do an average. You can record your averages on a Pico and then send it up to the stream. You could run every quarter second and throw it up to the stream. I let the time series do the averaging because the time series is designed to do averaging for recording and things like that. So, good question. Yeah.
All right, that's all the time we have. Thanks for sharing this interesting setup with us. And yes, thanks again to Justin.
Thank you. And if anybody wants this unit, please, preferable treatment to people that want to try IoT but haven't gotten into it yet. This is a good start. So. Yeah.
Plastic or steel?
So these are
Just to know.
iron. Yeah.
Oh, okay.
It was a lot of fun to actually create.
microphone, like some test words.
Test, test. Is okay? Yeah? Cool, perfect.
All right, welcome everybody. Can you guys hear me? Okay. Welcome everyone. Next up we have Neil Shah. He's a senior software engineer at Elixir and at Sentry, and he's currently maintaining the Python and Ruby SDKs for Elixir. And today he's going to give a talk about polyglot library development.
All right. So yeah, I'm Neil, and I build and maintain SDKs at Sentry. These are some of the SDKs I work with. So I'm mainly the maintainer of Python and Ruby, and then I usually read and sometimes once in 6 months contribute to the JS repo, the PHP, the Go. I do some Rust once in a while because that's like our geographically distributed sort of ingestion pipeline. And then I also work on our monorepo Sentry, which is like a classic Django, TypeScript, React SaaS product. So I wanted to talk about building stuff in many languages because there's usually a lot of context switching involved and so on. So let's go through it. So I always like to start by making fun of the audience because this is what most people today in the industry do, which is they're like full stack developers, and that's me on the right, because I work in many languages. So So yeah, what most people do these days in the industry, at least like 89% I would say, is like they work with some backend language, Python, Django, or Ruby Rails, or some Go backend, or some Node.js backend, and they then usually have some front end like JS, React, Vue, or some stuff like that. And usually that involves, I don't know, making endpoints on the left, making some APIs, making some functionality, talking to databases, and then on the front end you like render stuff, and yeah, that's basically what. But what we do at Sentry is, we're building stuff for you guys. So we are like slightly lower in the stack, but we also work across languages, and we want to sort of do the same thing across languages. So I don't know if everybody knows what Sentry is. If you don't, please talk to us. We have a booth outside. But overall, we basically build libraries for error monitoring, for performance monitoring, profiling, and so we want to hook it into your application and give you lots of insights about what's going wrong with your code. And then, so we want to make abstractions that sort of work across the semantic differences of each language. And there's some complexity and a lot of things we've learned over the years about how to deal with those differences and then sort of make something that works across everything. And sometimes it also doesn't work. So I'm also going to talk about those things. So this is the rough problem space that I will be talking about. API design is very important because it's like what the user eventually ends up using, and we want to keep that as simple as possible. There's also and the main differences come from like dynamic versus static type languages, like Python, Ruby, JavaScript, and then you have stuff like Rust, Go, and then lower level C, C++. I won't talk about those. In many languages, you can do monkey patching, like Python and Ruby, you can, and that makes it a lot easier for us to build libraries for you guys. And then in static languages, there's like stuff that goes wrong because we can't really do stuff we can in dynamic languages. So I'll talk about monkey patching a bit later, and then concurrency is like a huge area because every language has different concurrency models, and then you have to somehow abstract over those because we want to do stuff that also works across sort of concurrent programs. And I'll talk about packaging, like the ecosystem, and then finally, actually, the most interesting probably is just the human factors involved in doing all of this. Let's get into the meat. So API design. Sentry, we want to build a library for that is very, very simple to use. We want you to add just one line of code. You install the package, you do sentry.init, and then it just works magically out of the box. It does a bunch of stuff. It will capture exceptions, it will do performance, and this is our goal. Like we want to hide all this complexity from other programmers so they can get on with their daily job. Like we don't want you to think about other stuff. And so we want that magic to happen, and we want a consistent user experience. So we want to be as close to this API design as possible, because it's also important for adoption. It just makes lives easier, and there's also engineering. We're supposed to make everybody's life simpler, not more complicated. This is like a core design principle, and we try to do that. So in Python, you can actually do that because we monkey patch a lot in Python, and people of course get scared of that because you don't know what's happening. But it's on us to that's our responsibility to take care that we don't break any contracts and so on. That init call will basically do a bunch of stuff. It will go through your frameworks. It will go through. It will detect a bunch of stuff, or it will patch a bunch of functions and then hook into stuff, and it does a lot of things. But the end user doesn't have to think about all that, and that is possible in Python and Ruby and so on because you can patch stuff. On the other hand, the same thing in Go looks like that. And that's just a lot of cognitive overload for the end user that we don't want to expose, but we have to because in Go there's no choice. Because you have to compile stuff, things that check the compile time. There's a lot more manual stuff. So if you want to capture exceptions, you have to wrap the handler of your HTTP server, like here it's sent fast HTTP. And then you have to force the user to do all this stuff on their end, which breaks the sort of simplicity of our API that we have in some languages. And so that's like a big difference. You force the user to do stuff in their application, and that's just a lot more cognitive overload to deal with and so on. And we want to avoid that. So I will talk about possible ways to avoid that as well. The main differences come between this is one of the biggest differences between dynamic and static languages, as I said. So monkey patching is a huge thing. So dynamic, you can't monkey patch. In dynamic, you can. In static languages, you cannot. And then dynamic languages have duck typing usually. So you can just send random stuff to a function, and it's maybe breaks, but you can just make changes. In static, you have to make everything compile time. So if your language doesn't support generics, for instance, then everything gets way more complicated because you have to build everything for every interface and so on and so forth. What is a breaking change? As a library author, breaking changes are always a big issue. So in dynamic changes, again, contracts APIs are much simpler. You can keep the same API and just change everything under the hood because nobody cares about types. But in type languages, then you break stuff way more often, because if the API change, the types change, then that causes much more churn in terms of breaking changes. So, and then introspection, like, just as I said, like, we try to detect what frameworks you have and stuff. So you can do that in dynamic languages, but in some languages you can't like introspect at runtime what all is running in the environment and so on. So it's just like dynamic just gives you way more room to play around with stuff. And then static is, of course, way more secure and safer, like, because you have all this stuff, but then you lose that sort of flexibility to do stuff. So that's like a big trade-off between the two. Yeah, let's go over the monkey patching. I just saw this on Twitter a few days ago, and it said just big and greedy, and I think this monkey has cool energy. So he just cares about its mango and nothing else in the world. So yeah, what is monkey patching? So I don't know if you know what monkey patching is, but monkey patching is basically at runtime you can just change whatever. If a class, you can change a variable, a function, you can just change the function on runtime. So if a class is a foo function, you just say this class foo function is something else now. You can do that in Python, you can do that in Ruby. And that's very dangerous, of course, because you have to think about a lot of things. We have to be very careful when you do that, especially as a library author for everyone. We have to preserve contracts. We have to preserve what's something called idempotency so that you don't sort of break user behavior. But let's look at an example here. So let's say you have some class, and there's a function just like does something, returns a variable, or returns a number. And what we do inside Sentry now is we basically patch your function. This is roughly how Sentry works without all the bells and whistles. And we take a reference. So the old bar is like a reference to the original function. And then we make a new function which calls your function. And if there's an exception, we send some information to Sentry over the network, and we re-raise the exception. So the re-raise is very important because that's the idempotency. We didn't change the behavior of your application, but we did some extra side effect on the side. So yeah, this is how a lot of like performance monitoring also works, because you trace some timing. So you can, instead of the exception, you can have some timing around the function, and you can measure the time of that function. And so you have observability into your application, but you did not change the end user behavior. That is very important. So this is called idempotency, which is you just inject the side effect, but the original code stays the same. It does some extra stuff, but it doesn't change its sort of business logic at all. But in static languages, you cannot do that because, you can't monkey patch. You can't just change a variable. So instead, so this is a Rust example now. So you have the same kind of function. Of course, it's typed, so it's like it knows that it returns an integer. And then you have to make a wrapper function. So you have to expose a wrapper function that takes the original function and then does the same thing. So like Rust doesn't have exceptions, so it's just gonna do that result stuff, match it, and if it's an OK, you just do return it, and if there's an error, you send stuff over the network. But now the important thing is in Python, the user didn't have to change their code at all. They just needed to call sentry.init. But here, the user in their own application code will have to wrap their function with the sentry wrapper, because we can't do that. We can't do that at compile time. So this means that the user, if they want to do stuff in their application, they have to go and change all of the instances in their huge code base wherever they want to do Sentry stuff. And this like adds a lot of overhead to adoption as well, because people don't have time to just to do all this stuff. Maybe I don't know. So yeah, it's a lot more manual. Sometimes as I also said earlier, if generics are not there, so Rust has generics, but maybe Go doesn't, and then it's even more complicated because maybe you can't compile even, like you have to expose wrappers for every kind of type, and that maybe it just doesn't work. So yeah, that's the complexity we face. Another example of just stuff getting lost in translation. So I'm actually a Rubyist. Like I did Ruby for a long time, and I do both Python and Ruby now. But sometimes because in Ruby you don't have to write the return statement at the end. And I've actually pushed many PRs where I forgot the return in a monkey patch. I forgot the return in Python, and that actually breaks the contract because you have to explicitly return. There's very simple syntactic changes. Like Python and Ruby are like very similar languages. You can just translate between them freely. They do more or less the same thing. They have objects. They have functions. That you can put some state on the class, but it's just that because you're so used to like writing certain, because in Ruby I just like flow. I don't have to think about it. I just type. In Python, I have to then like do this bit of translation. It's the same when you speak a human language. You're learning a new language. You sort of you keep translating till you get to the point where you're so comfortable that you just start speaking it itself. Like it's I think the same sort of principle holds here. And so I just wanted to give a very simple example of like mistakes that you can do when you're like constantly context switching between languages. This happens all the time. And it's just kind of annoying. Let's talk about concurrency now. So this is a huge topic because what Sentry as a performance monitoring who wants to do is we want to track state even when you're like doing stuff across concurrent execution stuff. We want to track state, and now the language space is so complex because everybody's trying to innovate and make like the concurrent stuff better because it's like a huge unsolved problem in computer science in general. Nobody knows how to do concurrent programming well. I mean, we're getting better now with the newer models, but you would start off with the classic threads model. In Python, Ruby, Java, you have like threads or green threads or whatever. So threads are basically things that fork off and they carry some state in itself, and then you have problems with like sharing that state across threads. So you have things like locks and mutexes and synchronizing and so on. And this is just a very like sort of fragile model to work with. And so people sort of make async await and tasks, and then Python and Node, you have like promises and stuff. And that makes it a bit better, but then it's still very confusing because you have this sort of red-black type of thing. I don't want to get into too much in that. And then Rust has futures, which you sort of run in some runtime, which is also similar to async await. Rust also has async await now. And then Go came up with this completely different model called coroutines, which is like you write two Go functions and they can talk to each other over a channel. And then so I think there's like a lot of the concurrency space is going towards like sharing less state and instead message passing. And this is obviously pioneered by the Erlang model, which is the actor model, where you have these very, very lightweight things that talk to each other and then pass messages and then react to those messages via message queues and so on. So this is like I think the spectrum of concurrency is like threads versus like this message passing type model. And the thing is, when we build some SDKs, we want to abstract over all of those. Like we want let's say you have we want to follow some state across async computation, and that's actually a tricky problem to solve because. Yeah, let's say you have some authentication thing in your app, and then you set the user, and then you spawn like threads or tasks or futures or whatever. Like you start 3 different async things, but we want to track that state across all of those threads. So and then something goes bad in thread 2, and then we want to report that exception, and we still want to know that this was linked to that user. But because thread sharing state is such a big problem, it's not an easy problem to solve. So you need to do some extra bookkeeping across threads, and then how are we going to share that state? Like if you're just trying to solve this problem, do you do locks? But if you do locks, then that solution is not going to work for async IO or futures and stuff like that. And it does just like this. If you just make a solution just for threads, it's not going to work for like message passing type designs. So this is kind of a tricky problem to solve. I actually don't think we have even solved it satisfactorily, but we have some sort of solution which kind of works. So what we came up with is like, you just have a bag of arbitrary state, which is immutable. So you copy that thing, you have some bag of state, and then you copy that thing every time you start a new async computation. And then you can store the state that you want in that, but because it's immutable, you get rid of the lock problem and so on. So Sentry does it by something called a hub, which is just some name. It's like a very abstract thing, but it basically carries a stack of objects that you push and pop, and then you copy that over whenever you start some concurrent computation. OpenTelemetry actually calls this context, which is also like just an arbitrary dict, which is also just copied on whenever you want to use it. And this is like from the OpenTelemetry spec actually, which is a context is a propagation mechanism which carries execution scope values across API boundaries and between logically associated execution units. So that's a lot of words. But the main thing here is the execution unit. So what is an execution unit? It's like a thread, a task, an async IO task, a future, a coroutine. These are all execution units because they're sort of doing some work separately on the side. And so we clone this bag of state on each execution unit. And we do that for all of those structures, for threads, for tasks, for coroutines. So again, for static languages, this responsibility is passed to the user. So every time they set up, say, a Go routine or something in Golang, they have to do this themselves. So they have to do this cloning themselves. So they have to call Sentry and then do sentry.hub.clone. And even for Elixir Erlang, we haven't even like come up with this because that's sort of lagging behind in implementation. And it's like an open problem how we're going to solve it because it's like a completely different design, and I actually don't know how to solve that because the work is not instantiated there, but it's actually always exists and restarts on crash, and then you don't know when to clone. Like if you just clone at the start of the application, it's not going to work because you need to be able to add state later on, and so that's an open problem. We'll see what to do about them. And just to bring it back to the whole dynamic static discussion, what I said, so for Python and Ruby, we can just patch the threads. We can say, okay, whenever the thread is starting, when it's running, we just do some extra sentry stuff, and then we call the original run. Same for task. Like we hook into the task factory, and we just do our stuff, the cloning stuff, and then we let the user do their stuff. But in static, again, either you force the user to change all their call sites, so whenever they're spawning a thread, whenever they're doing a coroutine, you have to add all these clones yourself, which nobody's going to do because it's just super annoying. But what we can actually do is expose a wrapped interface. So we can either work upstream with language people. So we can talk to the Rust guys on GitHub and say, okay, can you guys expose a hook that we can use then to do some extra stuff? But that, of course, is a longer sort of development cycle. It might take 6 months till it goes through the whole RFC process and so on. And yeah, but we still do want to do that eventually. Or we can expose a wrapped interface. So this is a bit easier to refactor because the user just has to change the input. So if in Rust they're doing an std thread spawn, we instead expose a sentry thread, and they just basically need to find and replace all imports in their project, and then it just kind of works because we expose a thread interface that sort of hides the complexity. So this is like all wrapping up on the whole API design, monkey patching, dynamic static discussion with the concurrency stuff. All right, let's talk about some simpler stuff. Yeah, the concurrency stuff is a bit complicated. Packaging is also very interesting because we have to release stuff to all of these different ecosystems. So we have the PyPy, we have Ruby gems, we have NPM, Maven, Rust Cargo, and so we actually built some tooling called Craft, which uses GitHub Actions and so on to publish packages to each of these. So because it's like a deploy thing, but for each sort of language ecosystem. Semantic versioning is a big topic because it's actually very complicated because nobody knows what a breaking change is. Like, everybody talks about majors, minors, and patches, but what is a breaking change? So because we build a library that actually talks to a system outside, because it actually goes over the network, and then Sentry actually has a monolith. Does a breaking change mean just like when I break something in API in my library, or does it mean that I broke some or macroscopic behavior that like if it's talking about a network, does the other system count as a breaking change in my library? Because it's still like a holistic system, but so this is always like very, and we have like huge debates about what is a breaking change and what is not and so on, and sometimes it gets a bit out of hand. And then different package managers also have differences. So how do you deal optional dependencies is a very interesting question. So Python, for instance, has extras. In the setup.py, you can say these are extras. So you can say if Flask is present, you install some extra packages and so on. Because the SDK we want to keep as low dependency as possible. So the Python SDK has only 2 dependencies, only certify and URL lib3. So it's only using like these very 2 low-level libs because we don't want to impose dependencies on user space. So that's very important for us. So in Python, we can do it with extras. So if you say Django Flask, we can just put them as extras. But in NPM, for instance, it's not possible. Then you can either go the peer dependency route, or you make like separate packages for each sort of integration. So you make a Sentry Node package, a Sentry Express package, and so on. So, and we have that in JavaScript, for instance, where we have different packages for each sort of framework and so on. And this also affects like repository design. So is it like one big multi-repo, or is it like split it up into different ones and so on? Sorry. And then let's maybe talk about human factors, because this is also very interesting. Because when you have to do the same stuff across so many different packages and languages and people, you need a lot of processes to sort of make sure things happen. So one consensus is always a very, very hard problem. Because you have too many smart people in a room, everybody has opinions, and sometimes people will debate for 3 hours on some like really small difference. And sometimes as engineers, it's actually important to say, hey, we just stop debating, just do something, we ship it, we'll see what happens, right? But and so you need like somebody to drive stuff. So we also have we have weekly meetings where we try to reach consensus on things that we want to do, because sometimes you need to run it by other people. We have RFCs for even more technical things. So we have and it's all out in the open. It's on GitHub. You can follow our processes everywhere. And then sometimes they last weeks because everybody has a lot of comments, and then hopefully we reach like a conclusion of what we want to do, and then we ship and implement that. And this is just like sometimes it feels like this Jedi. I don't even like Star Wars, but sometimes it's really some of the consensus stuff really feels like trying to convince a lot of wise old people about stuff. And then also legacy is a huge problem because things you did long ago, especially for library development. If you're just building a SaaS product, you can like break stuff, it's okay. Like you can fix it in 2 hours, right? It's not a huge deal. But for libraries, like our contracts with all of you, and then you can't always break stuff that easily. So we have a lot of historical package, and pushing majors is not always like acceptable for small breaking changes. So yeah, it's just sometimes it's very hard to work around sort of not breaking stuff and legacy stuff. You need to justify it in a very sort of solid way. Yeah, and so yeah, I'm gonna wrap up now. Yeah, so just like what I was basically talking about is doing stuff in many languages. So like any language, reading is a huge part. I read a lot more code than I write in many languages because I'm just trying to see what my colleagues did somewhere, and then I'm just like trying to replicate it, translate it over into some other language. And then, yeah, you write stuff. You learn to write stuff in many languages. It takes a while because there's a lot of context switching. You learn to express yourself slowly. There's huge learning curves for some languages. So something like Rust is like way harder than something like Ruby or Python. And then, yeah, you learn to translate between all of those. Sometimes just writing is a very simple piece of code in Rust. It's like it takes a long time with a borrow checker and stuff. And yeah, design and architecture is yeah, very important because we are trying to build interfaces for actual programmers, and we want to keep them as simple, as easily understandable as possible. But sometimes you end up exposing a lot of complexity, and it's not always ideal. And then consensus and collaboration is a big part of doing all of this. Yeah, these are some references. So this is what we call the unified API document. This is our living document for what we all agree should be sort of the unified way an SDK for Sentry should look like. And we constantly update it whenever we make changes to it. The OpenTelemetry specification is also fun to read because they also solve very similar problems to us, but maybe in slightly different ways. So this is what the context I was talking about, that very heady sentence that was linked earlier. That's there. And yeah, slides I made with this very cool tool called Remark.js. So thank you.
Thanks a lot, Neil. We have some questions. The first question is, have you ever explored building a common core to all the libraries you're ever building, for example, in Rust or C, and then binding that using for and function interfaces?
Like generating, auto-generating stuff.
Yes.
Yeah, no, we never thought of that. But I think some other companies do that. Like AWS does that for sure. Like it just automatically generates a lot of bindings. But I don't think we ever looked into that. Also because like we're trying to do stuff that might not generalize over everything. So yeah. Something like that.
All right. And did you try in Rust macros or default implementation traits to inject your code without requiring an explicit wrapper?
I think our Rust SDK has a couple of macros, but I don't think we went very far into like exposing everything as macros. But there's something there. But again, I'm not a Rust expert, so I'll look into it. Yeah.
And yeah.
Yeah.
Okay. And do you need to reach 100% consensus to go on? For example, I think in this unified API?
No, not 100%. So usually we have drivers for each sort of thing. So there will be like 1 or 2 main drivers who will like make a proposal and stuff, and then people can leave feedback. But ultimately, it's on the drivers to sort of just decide and move on, because you need that. Otherwise, you can just reach a deadlock and nothing gets done. Yeah, something like that. No.
Great. Are there any more questions? You can also raise your hand if you have additional questions. Don't need to put them into Slido. Yes.
Thank you for the talk. In the Python SDK, where is the monkey patch performed? Like it's the import or it's the init function? And if you can elaborate a little bit on how it is
so
performed.
So the Sentry init function does a bunch of stuff. It will first check whatever libraries you already have. So if it finds you have Django, it will then run a bunch of functions that go in and patch Django's request handlers, for instance, and so on. Yeah, request handlers, database queries, all sorts of stuff. Yeah, middleware views and stuff like that. Yeah, and then we record all of these things, and yeah, you see them in Sentry. Yeah.
All right. Any more questions? And thanks again to Neil.
Thank you. Yeah, and we have a booth outside. If you guys want to talk to us, just come say hi.
All right, welcome everybody. Next up we have Danica Fine, and she's here to tell us about a houseplant alerting system using KSQLDB.
Yeah. Hey, everybody. All right. Yeah, we're going to talk about houseplants because I have an obsession. It's a problem. These are some of my houseplants. I have about 3 or 4 dozen of them, actually. So that's just a sampling of the best-looking ones, right? How many of you have houseplants? And you love them dearly, right? See, this is the crowd I want to attract here. Okay, the tech people that also like houseplants for some reason. So these are my houseplants. I really enjoy when they look like this, and not like this, right? This is a very depressing looking plant. I forgot to water him, and that's totally on me. It's tough to take care of houseplants. Like all the people that raised their hands, you know, right? It's an effort. Even if you only have a couple of them, you get caught up in life. And you come home and maybe you have something like this that just looks really depressing. So I figured, all right, is there a better way for me to be doing this, right? I'm a creative and technical person, right? So is there a solution that I could actually build for this, right? And you know, solutions do exist already, like ways to monitor your houseplants. Like I can hop on Amazon right now and probably have it at home by the time I get there. You know, some sort of way to monitor my houseplants. So of course there are better ways for me to be doing this, but I want to do it in an interesting way, right? I don't want to just buy something. So let's do it in a better way, right? The more interesting. Maybe not, oh man, we're just going to keep winging it. I will hold that. Is it the adapter? Okay. Okay. No, it's okay. I am flexible. Cool. All right. Yeah, no problem. It'll come back. I promise. There we go. All right. Who needs slides? I'll mime it all out. Really? I think I was in the one session where this happened, and anyway, so the whole point is that I'm going to do this in the more interesting way, right? I want to build something. I'm an engineer. I have skills, weird skills, but I've got skills, right? And probably most of you are here because you are curious and creative in that way as well. So I am a developer advocate. I used to, prior to this in a past life, I used to work with Apache Kafka building streaming data pipelines with that technology. And so when I became a developer advocate, I promised myself that I would only build things that were practical, that were useful to me. And what that means is that there's always going to be overlap with my hobbies, all right? And so this is the perfect opportunity for me to use Apache Kafka to solve a problem that I have, right, monitoring my houseplants. And I'd also wanted an excuse to do a hardware project, right, buy a Raspberry Pi, and this was it. This was the perfect storm, right? So I wanted to build an event-driven system that would help me monitor my houseplants. I'm not going to dive too deeply into this yet. We're going to cover each of these stages when we actually get into the talk. But this is what I had in mind, right? I wanted to build it on Apache Kafka and be able to receive some sort of alert on my phone, right? Because I'm a lazy person. I always have my phone with me, so that made sense. All right, so Kafka. How many of you have used Kafka before? Not nearly enough. Perfect. All right, so for those of you who did not raise your hand, don't worry. You'll get a quick primer on this. So what is Kafka? Well, it's a distributed event streaming platform. 3 simple words, right? What could go wrong? There's a lot in there that we should unpack, and let's do it together. Okay, but quickly though, because I only have like 20 minutes. So it's a streaming platform, okay? Not like Netflix, right? We're talking about streaming in the data sense, right? So over the last 10 years or so, we've been undergoing a paradigm shift in how we work with our data, how we process it, how we store it, how we move it, right? And so we're moving away from batch-focused systems that are typically slower, and we're moving towards streaming, toward real-time processing. So instead of waiting minutes, hours, days, weeks, months, I don't know, to batch data together and then process over it, we're instead pushing back, and we are building systems that react to smaller pieces of data as close to when those pieces of information are created as possible, right? Because data is more valuable the closer to when it's created, right? I think we can all agree on that. So there's a lot of technologies that can help you do stream processing. Kafka is just one of them. But there's a lot of benefits to it, okay? You're going to be increasing the accuracy of your data and results in most cases. You are obviously building a more reactive system, right? Because you're reacting to smaller pieces of data. And in the case of Kafka especially, you can actually build a more resilient system, and it's a very loosely coupled system as well. So there's a lot of gains that you can get from that. So Kafka is a streaming platform. More than that, though, it can serve as a messaging system, as just pub/sub, if that's what you need it for. You can use it as a persistent storage layer. Is Kafka a database? I'll let you think about that. And also, as we'll see, there's a lot of processing components in there so that we can actually unlock stream processing. All right, so it's a streaming system, but it's also an event system. What are events? Well, this is probably the most important thing. For those of you who did not raise your hand saying you knew about Kafka, to use Kafka successfully, you need to start thinking in events. They are critical to this technology, all right? And this isn't me asking you to rewire your brain, I promise. We already know how to think in events. As humans, as programmers, as users, this is a very natural thing for us to do. Every time you submit a form online, every time you use application log files to debug something, every time you get a notification on your phone, those are all events, okay? So those are examples of events, but what is an event? Well, it describes something that has happened. That's it. It's that simple, okay? So what do we need? We need a timestamp. We need to know when that thing happened. We need to know who or what was involved, and then any other supporting details, right? So going back to this system with these plants, right? I want to build a system to monitor my house plants based on their moisture levels, right? And so an example event would be, say, yesterday at 12:30, I had a moisture reading of this plant, and it was at 19% moisture level. Okay, so we have the timestamp, yesterday at 12:30. We have the subject of this event, which is this particular plant, and that supporting detail was that it had a moisture level reading of 19%. Okay, that is an event. It has happened. Another thing about events that you really need to internalize is that they're immutable. I'm so sorry if immutability is not something that you like. It just is what it is. And it's not me being a complicated person and telling you just to be difficult. Events describe things that have happened in the past. It occurred already, okay? We don't have time machines. I can't change that. Now, that's unfortunate because if that plant has a moisture reading of 19%, it's almost dead. It's a sad plant. So I would like it to not be that, but I'm not going to erase that event. I'm never going to delete that event because that thing happened in the past. What I could do is I could water the plant now, and sometime in the near future, we're going to do another moisture reading, and it's going to be, say, 70%, right? And so I'm not going to toss out that old event. I'm simply going to take the new one and append it to a timeline of events that describe the moisture status of this plant over time. All right? So when you work with events in Kafka, you're always building up sort of a timeline that describes the entities in your system, okay? So based on what you learned about Kafka being a streaming system that helps you move your data quickly and build a reactive system on top of that for stream processing, and the fact that you're communicating immutable facts, this is really powerful. For those of you who have embraced immutability, you know what sort of benefits you can get from that, right? Namely, that anyone can read that data, right? And you know that you're maintaining the integrity of that data, despite how many people might be reading it. Okay, so that's really valuable in a fast-paced system. Okay, so to understand, though, how Kafka is doing this, how it can move your data and stores your data, we need to look a little bit more into the architecture. So it is a distributed platform, for better or for worse. I know sometimes they get tough, but here we are. So how do we store data in Kafka? Well, we use something called a topic, and a topic is just a data set, right? Just a data set, okay? Consisting of these events. So it's effectively a timeline. You get data into Kafka using a client called a producer, and you write data as key value pairs. You can have as many of these producers as you want, within reason, but it's a pretty high number. From there, you get data back out using a consumer, all right? And a couple cool things about consumers. The first thing is that if I have an endless timeline of events that I'm constantly writing to, and I'm a consumer, well, I might want to take a break at some point. Maybe the node has rolled, I don't know, but that application might go down. And so it's beneficial for a consumer to keep track of where it's left off, right? So it does that using something called an offset. It's just a bookmark of where the last event that it read in that timeline, in that topic. Consumers can work together as part of a group, a consumer group, and this means that they are able to potentially parallelize the processing of the events from the underlying topic or topics. On the other hand, consumers can actually work completely independently. And this is a really, really powerful thing, that consumers are able to read the exact same data and get the same events from a topic without impacting the other consumers, all right? It's easy when you're learning Kafka to compare it to a similar technology, and messaging queues always come up. So a Kafka topic is not a messaging queue, it is a log, all right? Just like an application log file that you may use for debugging, as you read line by line through that file, nothing happens to the data in it, right? It's durably stored in that data, in that file, until the log rolls, which is similar in Kafka as well. You could define how long that data is stored. And until that log file rolls, anyone can come along and use that to build up that same state of that application in their minds and use it for whatever purposes they need it for. All right, so a Kafka topic is a log, very similar. The producers and consumers completely decoupled from one another. They don't care who, the producers don't care who's reading the data, the consumers don't care who put it there. And that is wonderful, because they can keep running even when the other one might go down. These topics are further broken down into components called partitions, that you see an example of that on the right here. And these partitions are actually themselves the append-only logs where the immutable events are stored, okay? And I'm not gonna get into this now, but by breaking the topic up into smaller components, we can actually store this data across the cluster, across the distributed system, and then we can also copy it and provide other copies for better durability and high availability of that data. Okay, back to the cool thing. All right, so Kafka. So now that we have an idea of what this is, we can actually build this system, right? And step one of building my plant monitoring pipeline is to have a cluster. Okay, that's it. We just got to get one of those. So I work for Confluent, and so we provide fully managed cloud-based Kafka. And so when I went into this project where I was going to be, heads down, building a physical hardware system, it was my first hardware project. Again, I'm really lazy, so I didn't want to maintain any infrastructure, so I used a cloud-based cluster. On top of this, there are some cool benefits that I get from using this cloud-based cluster. Kafka Connect, a way to move data in and out of Kafka and connect it to other sources and syncs. KSQLDB is actually provided in browser with Confluent Cloud, so you don't have to run any applications externally. And then also schema management is built in as well. So if you want to build something similar, just have a Kafka cluster running. They could be running on containers on your desktop or elsewhere. It doesn't really matter. You can actually run them on Raspberry Pi if you felt like it. So just have a cluster. Okay, step one complete. Now let's build the system. Again, we're going to do a little bit of hand waving here, but if you want to build something similar, how many of you do hardware projects? Okay, I'm surprised it's not more. It's the Python conference. Okay, so this is the equipment that I bought for this. The Raspberry Pi, completely overkill for this project. I didn't need that one, but there's still a shortage, so you take what you can get. Another thing to call out is that I was using these capacitive moisture sensors, and they're I²C components. What does that mean? Well, when you actually wire up these I²C components together, they're all going to communicate over the same input wires into the Raspberry Pi. And so in order to actually fetch data from the individual sensors, you use a unique address to access them, all right? And so that's great, but that means that every sensor needs to have a unique address, which they sometimes don't. And so in the case of these ones, which were only like $1 each, maybe less than that, I could only set the address to one of 4 values, which is very unfortunate because I have like 30 plants. So just know that going into this, I was only able to hook up 4 plants at a time. Those of you who do hardware projects, you'll probably say, yes, there are software ways around that. There are hardware ways around that. Doesn't matter, outside of the scope of this topic. All right, so let's write some data into Kafka, but let's not get ahead of ourselves. So my biggest piece of advice to anyone starting any project, because any project has some sort of data, is just to take a step back and understand what data you're working with, okay? This really helps me, even though I'm the only stakeholder of my projects, right? But it allows me to just see what the overall goals, what the long-term goals are for this project, and understand what fields are actually necessary right now, and what might be necessary later on, okay? So I have some goals to work towards, and I know how to reason about it. So the first data set that I wanted to work with are the readings that I'm actually capturing from the Raspberry Pi. Really simple data set. So it's just the percentage moisture that I'm capturing from that sensor. I get temperature for free, so I figured I'd add that in. And then I also need to identify the plant in question, right? So I took those fields, I created an Avro schema that I can store in the schema registry alongside my Kafka cluster. And great. Now all I have to do is write the data according to the schema. There are two ways to get data into Kafka, two main ways. You have the Producer API and Kafka Connect. The Producer API, this is your low-level sort of vanilla way of getting data into Kafka. It's really great, it's flexible, it's available in all of your favorite languages, and here's my lame joke, and some of your least favorite languages. So you'll want to use the Producer API when you either own the application that's generating the data, or you have access to it, right? So if I'm building a website and there's some very specific thing, like a click of some button that I would like to log that. I want to know when that happens and have that written to Kafka. I'll just add a producer. It's like 2 or 3 lines, add that in and write that data into Kafka as it happens. The other option is Kafka Connect. And Connect is it's a framework that runs alongside Kafka that runs connectors that are able to connect with sources in this case, and also syncs, as we'll see later on, to bring that data, translate it into events, and write it to Kafka. So for reference data sets that might exist in a database, or maybe you have legacy systems where you're constantly writing to Postgres and you want to be able to pull that into Kafka for processing, you're going to use Connect. So what did I end up using in my case? Well, I own the Raspberry Pi. I am the only author of this script, so we're going to use the Producer API. I'm specifically using the Confluent Kafka Python library, and I'm using the serializing producer because I have a schema that I need to serialize this data accordingly. You will recall that I need to reference each sensor by its unique address. And so what I did is I defined a hard-coded mapping. That should be a red flag. Hard-coded mapping of the sensor address to the plant ID, the plant that moisture sensor is actually in. Then within this script, every 30 seconds, I am looping over that mapping. I am capturing the moisture value from that sensor, computing the moisture percentage, creating a reading object, serializing it, and producing it into Kafka, right? So we're just doing this every 30 seconds. I've changed that value a couple times since I've played around with this, but 30 seconds seems to be a good interval for me to be collecting this data. And I will link to this code later if you are curious. Okay. So I'm producing these readings into Kafka. Great. Is that enough for me to be alerting on? Probably not. Every houseplant is different. If you don't believe me, get a couple plants, all right? They all have different needs, different time periods when they need to actually be watered. So a 20% moisture level for one plant might be completely different from a 20% moisture level on another one, right? One of them might need to be watered now, and the other one might have a couple weeks left, right, before it needs to be watered. And so I need a little more data to actually act on these readings. And so let's toss in some metadata, some hand-wavy metadata. So this is where I did a lot of research on my plants to understand what percentage moisture levels they are actually comfortable within. And I created a schema accordingly. So we have the plant ID, so I can join it back onto those readings. We have a bunch of names, like the scientific name, what name I actually gave it, because all my plants have names, then the low and high moisture threshold as well. How do I get this data into Kafka? Well, I don't have a database where this data lives, right? So I can't really use Kafka Connect to pull for those updates and create it and push it into Kafka, right? I'm not going to create a database to store this data because, again, I'm a lazy person, and there's really only 4 plants at a time that I need to monitor and write this data for. So I'm going to use the Producer API. I'm going to use the Confluent Kafka serializing producer again. And even though this is slow-changing data, right, and it should probably live in some sort of database somewhere, I'm going to write it directly to Kafka just out of convenience. But I don't want to have to log into my computer and write every time I want to write new metadata, right? So at the end of this, I want to receive alerts on my phone using Telegram. So I figured, let's use Telegram to also write this data, okay? And how many of you have used Telegram before? Thank goodness. Okay, so happy. It's the coolest thing. It's my favorite messaging app, mostly because it has a really rich API around it. And so you can make a bot. You're given an API key, and you can use that API key to validate your bot, write a Python script using their wrapper library, and define how people can have conversations with that bot and what your bot's going to do in response. And so what this means is that I can use it, build a Telegram application that's basically an admin console for me, that I can write this metadata to Kafka through. And so I define a conversation handler, how I'm actually going to interact with this bot. It's going to request at each stage different information from me. So I define this sort of like finite state machine of what happens in each stage. And then within the individual handler, I capture the user input, store it temporarily in state, ask the next question, and forward it to the next state of the conversation. So I keep doing this, and at the end, once I've fetched all the information, I can then just insert a producer here and write it from my phone. So I don't have to actually log into my computer now to write any of this data, which is wonderful. And so in the end, when I have this running, this is the sort of flow that I go through. It confirms the information and then produces it to Kafka for me. So what this means is that I can add new metadata. I can update metadata whenever I need to. But it's really that adding of metadata that's a big deal now, because you'll remember I have that hard-coded mapping of plants to sensors. And so that's not good, right? If I'm adding new metadata, I need a way to also update that mapping. Okay? And so I'm going to create a way to update that mapping from my phone as well and use this schema. So this is just a sensor ID to plant ID, very, very simple schema. And I'm going to add another conversation handler that allows me to select the sensor ID that I want to update, right? So the limited addresses that I have available, say which plant ID I want to map it to, and then that is in Kafka as well. Now, all I have to do is add a consumer now on my Raspberry Pi script to actually make use of that mapping, all right? So how do you get data out of Kafka? Consumer API or Kafka Connect. In this case, we're gonna use a regular consumer. And so before that, right when that script starts up, before it starts pulling for data, it's first going to read through that topic of mappings. It's going to build up a full mapping of the 4 sensor IDs, right? It needs a full mapping in order to start running, right? And then after that, it will start pulling for the data and then check for more updates on that mapping topic. An important thing here is that I'm not going to use any of those consumer bookmarks that I talked about. I want this consumer to start from the beginning of the topic every time, just so that we have that full mapping of 4 sensor IDs that we need to actually run. And to do this, I'm going to use a non-committed consumer, and these are the configuration values that I would use to set that up. And then also the topic that this data is being stored in is going to be a compact topic. What that means is that every so often, this topic is going to go through and look at old values per key and get rid of those. So it's constantly going to be optimizing the topic itself, and then our consumer is going to sort of minimize the amount of data it needs to actually go through to build up that full mapping. So now, within 30 seconds or so of me inputting new data, or a new mapping, the Raspberry Pi script is going to see that, and I can switch the sensor, and I can add a new plant to it. Great. Okay, all of that just to get the data into Kafka, and now we're ready. Now we can do something fun, all right? So now we actually need to do the stream processing and act on these readings. So how do we process data with Kafka? Well, there are options. I'm not going to get too far into this now, but here's a pretty quick summary. We have the consumer and producer API. You are free to build up an application of just a vanilla consumer, read the data from Kafka, do your processing, and write it back to Kafka. That's fine. It's really good for stateless processing, because once you add state into the mix, it gets complicated. Kafka Streams is a purpose-built Java and Scala library for stream processing. It is adept at handling state. And it's able to, you can run multiple instances of the same application, and it will fail over any sort of input partitions that you have one instance processing. If that instance goes down, it will fail those partitions over to the other ones and take the state with it, so you don't have to worry about that. If you don't like Java, which is completely reasonable, I almost don't, we have ksqldb, which is a SQL wrapper on top of Kafka Streams, okay? And this is what we're gonna use today. So ksqldb, how do we actually use this for stream processing? Well, the first thing you have to do is get the data into Kafka. Well, it's there, but you have to get it into the ksqldb application now. Define your inputs. And there are 2 sort of first-class citizens in ksqldb. There are tables and there are streams. Streams represent ongoing series of events, and tables represent only the most recent value per key. It's kind of like a compact topic. So looking at this metadata first, we want to bring this in. This is going to be a table, right? Because anytime that I'm updating the metadata, I want the most recent value to be reflected in my processing. I don't want to look at the old metadata that's assigned to that plant. I want the new stuff. And so I'm going to use a create table statement to set this up. I'm giving it a name, houseplant metadata. I'm pointing to the topic where that data exists, and I'm specifying the value format, which is Avro, because we wrote Avro schemas. The cool thing here, and the reason that I spent all that time writing a schema, is that KSQLDB as a consumer looks at that topic, knows it has a schema, goes to the schema registry, looks at that schema, and uses that schema to parse the fields and types for this topic. And so I don't have to type out any of them. The only thing I have to do is define the string ID, just because it needs to know which key we're using, because it needs the most recent value per key. Okay, so I'm going to take that SQL, I'm going to run it in the Confluent Cloud Console, and then that data is going to be brought into this application. For the readings, every message is relevant in this stream, so it should be a stream. Very similar syntax of create stream from create table. You point to the topic, specify the value format, and you can run this, and this is available as input. All right, the data is in the application. Now let's do something. First, let's enrich the data sets with one another, right? The readings aren't good enough on their own. We need the metadata. And so I'm going to do just a regular join. And I want this to be persisted to another stream, so we're using a create stream statement. And I'm going to execute this join, just an inner join, selecting the fields that I actually want to be output here. But I want this data to be persisted somewhere. And if I only ran this query, this select statement, it's going to give me everything that currently exists in that topic. But I want it to be persisted. I want this to be a long-running query. And so I'm going to use something called emit changes at the end. So what that means is that every time a new event flows in, we're going to execute this query, execute the join, and append that to this stream that we're creating. All right? So this is the intermediate stage where we're just joining the data and making this full stream of data available for the next step. And so this was called a push query, right? And this is contrasted with a pull query where it's just pulling as output what's currently in that topic, right? All right, so now let's act on it. What is the goal here? Whenever a plant has enough low moisture readings, I want an alert on my phone, right? But I'm taking these readings every 30 seconds. That's a really, really close interval for me to be receiving alerts on my phone, right? Every time there's a low reading, I don't want to get an alert every 30 seconds. That's ridiculous. So 6 hours, that seems like a good amount of time for me to receive an alert and act, right? Go back and water my plants. Obviously, I can't get back to California in that amount of time, but it gives me enough time to tell the person who's taking care of my plants to, okay, make sure you water this one, right? So again, I'm taking these readings every 30 seconds. A 6-hour period, that's what I want to send alerts within. And so it's probably good enough if within a 6-hour period, if I had 1 hour's worth of low readings, right? That plant probably needs to be watered, right? And these moisture sensors, they're not perfect. I get false high readings, false low readings, but the general trend is that they go down over time. So 1 hour's worth in 6 hours, that seems like a good enough thing. And so what that means, doing a little math, is that I need at least 120 low readings within a 6-hour period in order to trigger an alert. Okay, so this is the query that does that. This is the bulk of it. All right, few key details here. First of all, I want to receive an alert every 6 hours. So let's window. We're going to window over a 6-hour period, and it's going to be a non-overlapping tumbling window here. When an event flows in, the first thing we're going to do is we're going to figure out which bucket, which window it goes into. Within that window, and per plant, right, because we're grouping by plant ID, whenever a moisture reading is lower than that low moisture threshold, we're going to count, right? And only when that counter is above 120 are we going to output something. You might be asking, well, if you're still getting readings every 30 seconds, wouldn't I just get an alert after we hit 120, 121, 122, 123? Great question. No. So at the end, I have emit final. As opposed to emit changes, where every event could generate an output, emit final says wait until the window has fully closed, and then assess and generate a result if you need to. And so what this means is that only after we've gotten to 120, after the window has closed, if that state says we have over 120 readings, we will generate an output result according to this select statement. Okay, cool. I know, I'm going to be over time. Ready? Okay, so that is cool. Now all I have to do is get the data out of Kafka. Now I have a message that says this plant needs to be watered. And now I need to get it out so I can actually use it. And I want it on my phone. That's all I want. It's a pretty easy ask. And so we already saw how to use Telegram as a producer. So let's now use it as another producer from the Kafka side of things, right? I want to move that data out into my phone. You'll recall that I defined a bot. I received an API key. With that API key, I can access the individual conversations that I'm having with this bot, and I can identify my personal conversation with a conversation ID. The Telegram API is super cool, right? So I can build up an endpoint using that API key and that conversation ID, and I can send data directly to that conversation. Okay? So building up that endpoint, why is that useful? Well, we have something called the HTTP sync connector, and so what all this needs is an endpoint to send data to. You point to a Kafka topic, and once you run it, every time a new event is generated on that topic, it's going to send the data to that endpoint. Okay? So all I had to do was point to those two things, and this is run completely in Confluent Cloud. I don't have to run it externally. It's just long running for me. So I use this to extract the relevant data from that last topic that we just built up. And so this is the alert that I receive on my phone. I added their names to make it a little more personal, so I feel bad. Okay, so I'm pretty happy when I get that. I mean, I'm sad because the plant's dry, but I get pretty happy. So the plants that I have hooked up to this, I completely rely on this system to tell me whether or not they need to be watered. Like, I don't even look at them until I get a text, which maybe that makes me a bad plant parent, but whatever. Okay, so I'm pretty proud of this. This was my first hardware project. It was a cool project for me to play around with hardware, build something interesting with Kafka, and solve a problem that I had. Why should you care? Why? Well, I tricked you because you learned a lot. So every streaming data pipeline is going to have some combination of these components. You need to know how to get the data into Kafka, right? And I showed you how to use the producer API, how we could use Kafka Connect as well. You're going to do some sort of stream processing, and I gave you some of those tools and specifically went into ksqlDB on that. And then you're going to use maybe a consumer or the Kafka Connect to get data out of Kafka later, okay? All of those components, you're going to use some of them to actually build up your streaming data pipeline, all right? And now you have those tools, so get on out there, build something cool, all right? I have some resources up here as well as the source code if you're curious to see how it was set up. And please go check them out and find me later for questions. Thank you so much.
Thanks so much, Daniel.
Yeah.
I think before you all run off to lunch, so the lunch is going to be served at 1:15, so we have some time for a little more questions.
Haha, you're stuck here.
Or you can ask Daniel again the break as you want. But if you want to go now, that's also fine because the official time slot is over. So the first question is, it's more of a hardware-related question, but how could you make your setup work in a garden?
Oh, man. Well, Raspberry Pis aren't waterproof. You guys, you're so funny. Yeah, I did look into that. Unfortunately, I care about indoor plants more. The cool connection that I do have is that my boyfriend's sister runs a farm. And so that is actually a project that I do want to get into. She has agreed to let me put a bunch of hardware components everywhere and see what we can get out of that. But yeah, honestly, I wanted to set it up in my own garden at home, and I kind of gave up after build and housing for everything, right? Because you have to make sure everything's waterproof. That said, there are some other sensors I've seen that are more expensive, they're more robust, that can actually be outside. There's also some like wireless sensors as well that work better outside. So it's flexible, and you could totally do this. I mean, as long as you pick your component, bring your own component, right? And then send it off to Kafka, and then the rest of it's the same, effectively, hand waving, right?
Great. And maybe the most important question, how are your plants doing with all the extra monitoring? Are they doing better than before?
I'm a helicopter parent now. Yeah, they feel like they can't escape. They don't get to live their lives. Those ones are doing really, really well. Like I said, I completely rely on the system for the plants that are hooked up to it. I don't touch them until they actually need to be watered, until it tells me to. They are probably doing better than the rest of the plants, honestly. So it works. And that was like the coolest thing to actually see that it does work. When I first started running it, it took every ounce of my being not to water those plants before I was told to water them, right? It's like, oh, but you look, and then no, it's like the science says you're not ready to be watered. Okay, I need to wait, so.
All right, then thanks for sharing this awesome project with us. And
Yeah.
Yes, you're ready for lunch. If you have lunch boxes reserved, you can pick them up at the registration counter. If you have a ticket for the Osteria, then you can go there as well. And all the others, you can go to the lunchroom, which is in the main hotel room. All right.
Great, thank you so much, everybody.
speaker is Patrick Schemitz, and he will talk about the REST APIs and how to document them, and yeah, and do so without repeating yourself. Thank you. Sorry, one more thing. There's Slido if you want to ask questions, so please do so while watching the talk. Thank you.
Salve, mi chiamo Patrick. Questo non è la prima volta che sono in Italia o a Firenze, però è la prima volta che faccio una presentazione a PyCon.it. Purtroppo il mio italiano è così e per questo motivo devo continuare in inglese. Scusate. So, how not to repeat yourself in the context of a REST API with Connexion, YAML, OpenAPI, and Pydantic. A short tour of what we are going to talk about in the next half hour. A brief overview of the company I work for and the project. What is Connexion and how is it supposed to be used? Why that usage leads to repetition. And then the bulk of the talk will be how we get the data we need to avoid that repetition and generate the OpenAPI for us. And then, of course, coming up with a nice and Pythonic interface. A word of warning, I will show quite some actual Python code in this talk. I hope that's okay. So, who are we? The Solute GmbH is an e-commerce company with a little over 150 people. We employ people all over Germany, but the bulk of us live in Karlsruhe in the southwest. We started out purely as a price comparison website, billiger.de. Still exists, still going strong. We get over 100 million offers from several thousand shops, and these shops then pay us for high quality traffic. That is the business model. We also provide access to these offers and further data that we aggregate via a syndication partner API, which is basically kind of like a REST JSON version of the website, except it also works internationally. And this API will be the subject of this talk. We are a Python company. There is, of course, some JavaScript on the website, but everything else is Python. So, as I said, Python company, the syndication API uses a REST framework called Connexion. In conjunction with Flask and Apache, we use Pydantic for data models and mostly Postgres for storage. There's also some Redis flying around and Solr for search. Connexion is developed by Zalando, a rather large Berlin-based fashion online shop. It's a REST framework that does request validation and provides a nice Swagger user interface, which our partners can use to explore the API. It is apparently a bit more flexible when it comes to request URLs. You can do weird things. And this is a quote from the README, the Connexion README. With Connexion, you write the specs first in YAML. Connexion then calls your Python code, handling the mapping from the specifications to the code. Okay, specs first, sounds reasonable enough for an API. But we're gonna have to write OpenAPI YAML. What does that really look like? Well, okay, that's maybe a bit chatty. Let's see what we can make of this. So apparently there is a section paths, and underneath this section there is an endpoint, looks like an URL path. The URL path contains offer IDs in curlies, resembling format string. Okay, then get is very suspicious. This is an HTTP verb, so maybe there's also post or delete or whatever. Operation ID, that is quite obviously a dotted notation module.function name. So I guess that's what Connexion will map this stuff to. Description, okay, parameters, offer IDs, we already saw the offer IDs. They were part of the endpoint path, so it's in path, as it says there. and it's a list of integers. Okay. With images is in query, so apparently it's a query parameter, question mark with images, and then a Boolean defaults to false, okay. And then there's a response, which we come to later. Okay, so what does that getOffer function in the operation ID look like? Okay, that looks innocent enough. The arguments, offer ID, and with images, they will be filled by connection. Then we do some work, we fetch offers, we prepare images, we return some result. Okay. Except that is not the function we would write, I hope. I mean, we're professionals, and professionals have standards, right? And this is a public-facing API. So what we would write is, of course, this. See? Now, what's wrong with this? Why is this slide titled The Ugly Truth? Well, it is terribly redundant. See? All the red bits are the exact same information that's already in the OpenAI YAML. So it violates the dry or don't repeat yourself principle. And furthermore, it uses type hints as type hints, and that is a bit of a pet peeve of mine, because I really can't stand type hints. So we shall put them to some actual use here. So let's see if we can't deduplicate all this, beginning with the easiest one, with a docstring. So getting the docstring of a function is easy. Just use .doc on the function object, that is the bold red code. And the docstring, I'm talking about the actual string here now, the structure, the syntax, if you will, of the string, contains several parts. There's the function documentation, which itself consists of two parts, the summary and a lengthier description. And then there's the parameter description with the @param markers. So what we do is we split at words starting with an @ The function documentation is everything that's before the first @ And everything that follows is part of the param description. So the function documentation is split at the first empty line. That's the double new line at the very right of the slide. And the first part, again, is the summary, and the second part is the description. Now, this parts thing is an alternating sequence, an alternating list of param and the rest of the string, param and the rest of the string. So in order to clean this up and make this usable, we get an iterator over those parts and zip the iterator unto itself, thus unflattening the list. Now we can iterate pairwise over this, and value is then the remainder of the string, offer IDs up to 100 offer IDs, this part, and we can split this at the first white space, so we have the parameter name and the actual description. And then there's this text verb dedent, which will deal with the indentation. You see, this is a doc string, this is a multi-line string, and the indentation is all wrong, and dedent will fix this. So, and now we have everything we need here, like the summary, the description, the parameter descriptions. Nice. Brief recap, like function.doc will get the doc string, then the text verb dedent for multi-line strings, nice to have in the back of your mind if you ever have to process them. String.partition on a separator is a bit underused in my opinion. It's like string split with max split equals 1, but with a nicer interface because it will always return 3 values, like left of the separator, right of the separator. And if the separator isn't in the string, it will still return exactly 3 values, but the latter 2 strings will be empty. And this iter/zip thing to unflatten lists, we use it for pairs here, also works for other triples and so on. Okay, so that's already better. The red has receded. Next up are the arguments and the return value. To get to the arguments, in the inspect module, batteries included, there is a function called getFullArgSpec, which returns everything we need. the little star as the first argument here, by the way, in case someone hasn't seen this yet, this will make all further arguments keyword-only arguments. That means I need to provide the argument name when I invoke this function. Makes the interface, or our interface here, work a bit simpler. Thus, args and var args and var quarks and defaults are all none or empty. And everything we need to know is in KW only args and KW only defaults. And then there's the annotations. The annotations dict contains all the type hints, like typing.list of int, typing optional of bool. Keep the latter one in mind. And then there is a magic key return, a string return, which contains the type hint for the return type. And I think that's a very neat detail, because how could you hack this? Could you hack this? What happened if you named an argument return? Well, you can't, it's a keyword. So I think that's a very neat trick that they pulled there. Okay, again, brief recap. Inspect.get full argspec, then the star to make the rest of the arguments keyword-only arguments is a very good idea to have in mind when you have a function with more than 2 params. It's probably a very good idea. And spec.keyword-only args, spec.keyword-only defaults, and spec.annotations is what we're going to use later on. So now it's time to go to the schemas in OpenAPI speak, or models as Pydantic calls them. Remember, this was the first OpenAPI YAML slide. So the response. The response in the very last line, $ref references something somewhere else in the OpenAPI, /components /schemas /offer response. So this is a different part. Looks like this. This is how schemas or models are described in OpenAPI. There's this components section, subsection, schemas, and then there's an offer, which has properties. It has an ID, it has a name, it has a price. They all have types, integers, strings, whatever. They can have a description, and since this is the city of Dante, I was going to be a bit poetic with this. An example. But those schemas can also reference each other, as you can see with the offers response, which has only one property, the items, which is a list of those offers above. Okay, so this is straightforward. If, again, maybe a little chatty, verbose. Let's see how this looks in Python. As I said, in Python we use Pydantic for this, which has 2 nice effects. First of all, it checks our output for correctness and completeness. And second of all, as we will see momentarily, Pydantic can already generate OpenAPI structures for us. But first, let's a brief look at the model. It inherits from Pydantic Python base model and is composed of Pydantic fields. The first argument, by the way, for fields is really the ellipsis. This is not me omitting some code. This signifies that the field has no default value. If the field had a default value, that would be the first param. We can also add documentation, like the description and an example. Really nice. And as I said, Pydantic can generate for us the OpenAPI schema structures. There's a function called pydantic.schema.schema, which takes a list of classes that have to inherit from base model, and we're basically done. This is what this will generate. There's a little tweak. It's in the wrong place. Like instead of components /schemas, it's under definitions. So we have to refill the dictionaries a little bit. I'm gonna gloss over that. It's basically exactly what we need. So again, summary with the pydantic.schema.schema list of classes. And it's even quite easy to generate that list of classes automatically if we put all the classes in one module. Because then we can use dir on the module to get all the symbols. Dir in production code, that's weird. And get the appropriate attribute with getUtter. And then we can check if the attribute is a class and a subclass of Pydantic base model. And if this is the case, then we can include it in our list for pydantic.schema.schema. By the way, we could also have used something in the inspect module, inspect.is class, to figure out whether it's a class. So now we almost have everything we need. We just need to add the path and the HTTP method. And we have to find out a nice Pythonic way to integrate all this, to tie it all together. So, and anyone who read the elevator pitch has already read the spoiler. What could be more Pythonic for this use case than a decorator? So this is what we're striving for. The add endpoint decorator takes a path, takes the HTTP method, and it's just wrapped around our Python code. And that's all there is to it. Now we only write Python. There's no redundancy, there's no open API, there's no YAML. That's pretty smooth. How do we get there? A brief refresher on decorators. This is the general structure of a decorator class. Dunder init creates the decorator, and dunder call wraps it around a function fn. And dunder init, in our case, will just take the path and the method and store them. And dunder call is then called with the original function, getOffers, as fn, and it can then extract whatever information it needs from fn. But in the end, it will just return an inner wrapper function that will be called whenever the original function is invoked, and the args that are intended for the original function that it will then pass along to fn, the decorated function. And this add wraps just fixes doc strings and stuff like that. So let's fill this with life. Dunder call is the perfect place to collect all the function info. We can get the doc string of the fn and process it. We can get the full arg spec of fn and convert the keyword-only args into these YAML-like parameters, getting the type from the annotation. And the description from the doc string. We can check if the param in curlies occurs in the path, in the endpoint path. And if this is the case, then apparently it is a path variable. In is then set to path, and otherwise it must be a query parameter. And we can even check if it is optional or if it's required, even though this is a bit of a hack, because we look at the string representation of the annotation and see if the string representation starts with typing.optional. That is why I told you to keep in mind this typing.optional thing. So I'm glossing over the actual get schema function, the third row from the bottom, because it is tedious. It just does a lot of if annotation is int kind of work, but it is also complicated because it has to deal with recursion and stuff like that. So I leave that for the code in the repo. I'll put a link in the last slide. So now we have the docs and the params. We're almost there, I promise. Let's finish this off. A path, if you remember the first OpenAPI slide, has one entry per HTTP method. This is the square braces set of method, and before that, the path. Then it has a summary, it has a description, it has the parameters, it has the module.function name as operation ID, fn.dundermodule, fn.dundername, okay? And it has a response, whatever schema we mentioned in the type hint for the return. So now we need to collect all these information about this one endpoint into the paths module variable. And after we import all modules that have endpoints, that contain endpoints, this paths thing will then contain the open API structure for all the endpoints. So to create the Connexion app, we create an instance of connexion.flask app. We combine the paths from the last slide with the Pydantic schemas from a couple of slides back, and then we add all this as an API to the Connexion app. And then we run it. Et voila. All the YAML is gone, all the OpenAPI is gone, the redundancy is gone, and all the metadata we need comes from inspecting the Python code. So, to summarize, instead of writing YAML and OpenAPI, we write Python. And then we use inspection to collect all the metadata about endpoints and schemas. Thus, we get rid of all the redundancies, because these redundancies, no matter how disciplined we are, sooner or later, they will lead to inconsistencies. And also, we put the type hints to some good use, because now they are enforced by Connexion. So, that's it. I hope you enjoyed the ride. Have a nice afternoon. Buon pomeriggio.
So for the questions, we have one from Slido, and that's what's wrong with the typing.optional? They ask.
With the typing or optional?
With typing.optional, like using that.
It's a bit using the string annotate, the string representation of the annotation, or what exactly? I'm not entirely sure I understand this correctly. The string notation, I don't think it's wrong. It's just a bit surprising. You wouldn't normally expect, like, if you have the proper type annotation, then look into the string. I haven't come across a problem with it, really.
Okay. That's the only question we have. So thank you very much. And that was a great talk.
Good. Another question?
Yeah, we just got a few other questions. Sorry about that. So isn't it YAML good for non-technical stakeholders to follow the specification?
May I read this?
Yep, sure.
Isn't non-technical stakeholders? Oh. Yeah, you can still access the YAML. We just generate it on the fly. You can actually, the Swagger UI still works as well, because with this, the Connexion app can still provide, and you can check this out in the source code. The Connexion app will still output an OpenAPI.yaml file for you if you access the URL. So we still have this feature. We just don't have to write it by hand.
I see. Another question is, why do you use Flask instead of FastAPI? I believe that FastAPI generates the OpenAPI spec automatically as well.
Yeah, I anticipated this question, yes. This is a historical thing, basically. So when work was started on this project, FastAPI, the very first commit was 2 months old. Whereas Connexion was already 3 years in the version 1 range. Like, that is the thing. Today, if we had to restart this project, we would have picked FastAPI, because it already has this decorator, basically. And well, now we can't switch, because we are already using those more sophisticated request URLs. So we are stuck. So the best we can do is, like, lessen our pain. There's a parallel talk, like 2 rooms down, with a no-holds-barred web framework thing. This is one of the talks that I will definitely watch once they are on YouTube.
Great, thank you. Thank you very much. Okay, so our next speaker is Flavio Percoco, and he will talk about creating software that is simple to use and easy to maintain. Thank you.
Cool.
If you have any question during the talk, please ask them on Slido, and they will be answered at the end of the talk.
Cool. Although, yeah, so the talk is called Starting for Simplicity. Before we get started, I do have a couple of disclaimers. One of them is related to what he just said. I am Italian. I tend to talk a lot. So hopefully we'll still have time for questions at the very end. If you see me talking really fast, it's probably because I realize that I'm running out of time. The second one is that I've been talking with some people around the conference, and every time they asked me what I was going to speak about, I said the title of the talk, and they were like overly excited about the title, said that it was a catchy title, it's a hard problem and stuff like that. So hopefully I'm going to meet your expectations. Just want to say it like super clear right now that I'm not exception to the rest of 8 billion people that went through COVID and became super enlightened and philosophical and all those things. I also did sourdough and all those things, which basically means that I am going to do a talk that is very philosophical. You're not going to find here like a checklist of things that you're just going to follow and are going to solve all of your problems. What you're going to find here is hopefully some ideas, mental models, and things that you can apply and like think about that will help you reason about what simplicity actually is and how to approach it. I do not hold the answers to all the questions that you might have, but hopefully some of my experience will help you out here. That's me. If you know anything about me, is that probably I spent all around almost 10 years working at Red Hat with a small break of 2 years at Elastic, but now I've changed jobs again. Actually, I left Red Hat this month and I went on a different company, which is called Pace Revenue. Unlike the rest of the industry, we're not firing people, we're actually hiring people. So if you're interested, do reach out after the talk. And yeah, one more thing, I guess, is like I've been coming to this conference for so many years that my wife actually decided it was easier for her to help in the conference and contribute than getting me to not come. So if you like the plants and all the landscape designs and the garden, you have her to thank. This is not coming from the hotel. This is all planned by the conference, and it's all been contributed. So do reach out. And with that, I just earned like 10 husband points at least. So that's good for me. I just want to make sure that she watches the first 5 minutes of the talk. So simplicity or complexity, what are we actually defining? So if you're here, it's because you want to know what simplicity is. But before we know what simplicity is, we have to actually dive into the complexities of all the things that we have to face on a daily basis. So I'm going to be talking about complexity, simplicity, and I'm going to be saying things many times, mostly because I don't want to talk about a product. I don't want to talk about an HTTP API. I don't want to talk about a CLI tool. I want to talk about problems that are complex to solve and that we need to solve in some way so that others can approach them as well. But I am responsible to keeping you awake for the next 30 minutes. So I am not going to hold you here for 30 minutes and then give you the definition of what I believe the simplicity is at the very end. So I'm just going to right off the bat tell you that to me, to simplify something is actually abstracting all the complexities that there are in that specific problem. You get a problem that is very complex, you understand all the complexities of that specific problem, you break it apart, and you start simplifying it. Which doesn't mean that you're hiding everything of those complexities. Like some of those complexities are still going to go through, and they're still going to be exposed in whatever solution and whatever definition that you find. But you are abstracting it in a way that is easier for people to approach it, right? You don't want to dumb down the things that you're working on. What you want to make sure is that those things are abstracted in a way that the knowledge needed to work and use those things that you have just abstracted is the bare minimum for people to actually be able to interact with them, right? You want to reduce the amount of knowledge that people need to actually be able to interact with the things that you're building and the solutions that you're working on. And I think a good example of that is this equation here. Don't let it fool you. I don't think I understand not even the 20 or 30% of what goes behind this equation here. But if you know this equation, if you've seen it before, is the equation that a human called Albert Einstein came up with at some point in his life. But kind of like defines the mass energy equivalence for the relativity theory that he worked on. So bear with me while in the next minute I'm just going to butcher everything that he did. But the beauty of this, like I don't need to understand everything that goes behind this equation to appreciate the beauty of it, right? I don't think he woke up one day and said like, yo, you know what? I'm just going to work on an equation. It's just going to have like 2 parameters. It's going to be dope and everyone's going to like it. What he did is actually he said like, well, this relativity issue here that sounds extremely interesting and that I want to spend time on. And he started like breaking it apart, finding solutions for the various things that he needed to work on. And eventually he found what he believed and still is, honestly, the definition of, again, mass energy equivalence. And he did that by following a process, right? But in this equation, as simple as it is, there's a lot of complexity and a lot of difficult things behind it that you don't need to know to actually understand. Like you can read enough about relativity theory to understand what this equation is supposed to do, and you maybe are good with that. Like you're like, okay, I know enough. I don't need to just like dive into like all the details of what it's exactly doing to actually appreciate what it does, unless you really like it and you enjoy it. So why is this really important? Why are we trying to simplify things? One of the reasons is because we need to make things more mundane. And this is, mundane is probably a bit of a harsh, extreme, borderline crazy way to define what I mean here. But it's on purpose. We need to start making things more boring so that we can start focusing on other stuff. Like we cannot keep navigating the entire world with all the complexities that it has. And we need to make them easy for people to use. We need to make them easy for people to interact with so that they can focus on the things that they really care about. And I guess one other extreme example, like as software engineers, we really like going around saying like, yeah, one of my jobs is automating my job away, right? As product designers or like people working on complex systems, our job is actually to make them simple so that they become mundane for people to use. And a good example of this is imagine a doctor that needs to operate on you. Right? And they need to use like a new arm that is like has a lot of software and a lot of hardware in there. Like you don't need the doctor to understand exactly what's happening in that piece of machine. You need the doctor to just like focus on not killing you. And the way that the doctor can do that is by you like extremely simplifying the interfaces that he has to interact with, he or she has to interact with, so that he can keep you alive and like complete his job properly. So that you can walk away in one piece. But again, we need to focus on, like part of the goal here is to focus on making things as mundane as possible, as simple and approachable as possible for other people. And I don't really pretend to know like all the complexities that you might be dealing with, but I would dare to say that this can also be applied for even your own life to great extent. Or as Nassim Taleb put in his Skin in the Game book, simplicity can, sophistication can at some times be extremely degradable, I guess, or can degrade the value of the stuff that you're building. He was not talking about complex system. He was not talking about, building solution. He was basically talking about putting yourself out there and like having skin in the game on the stuff that you're investing on. But I found it extremely interesting how simplifying systems that seem to be extremely sophisticated and complex for other people can also help into making everything more approachable. And we can say that about many things in life right now, like even whether it's like investment itself, like software solutions and like CLI tools, anything like that. You want it to be as powerful as possible, but you don't need it to be extremely sophisticated for you to have the tool and consume it. Okay, so I've roughly kept you already for 10 minutes awake about like this philosophical rant. So I'm just gonna go into some more specific mental models that I believe can help with the whole thing. Some of them might sound obvious, so bear with me. But again, like this is not a checklist for you to just like follow through and have everything solved. So the first thing that you need to understand is like who you're simplifying for. And nowadays we tend to always define the persona. We always tend to define a specific type of user, excuse me. that is going to be using the tools or like approaching the stuff that we're working on or simplifying. And that is all great and fine. You define your admin user that is using your cluster, like, or administrating your cluster. You define the user that is consuming your API. You define the user that is consuming your product. But we need to take it a step further. And product managers in the audience, if there's any, are gonna say like probably, okay, yeah, that's basically part of my job. But these days you'll often find that in every product manager call, there's always a UX designer or like even a UI designer. And the reason is because the product manager cannot hold like all the knowledge. They can collect the requirements for users. They can collect a lot of information from the outside world. But the ones that are holding the knowledge of how the system actually works are the ones that are actually doing the whole implementation. So people that are analyzing the way users actually interact with your product, people that are analyzing how the UI is being built, people that know how the backend actually works. So you need more people to actually understand all the complexities of the system that you're building so that you can properly build a solution for your users. So you need to know the personas you're talking, the ones that you're building the solution for, but you also need to get involved. Like, you also need to get other people involved so that you can understand better where they're coming from, what their needs are. Because users can have a lot of requirements. They can tell you exactly what they need, but the way that you implement that will really depend on the system itself and the way that your product works. And again, in this case, it can be an HTTP API, CLI tool, whatever, like a UI, whatever you need. Everything has a user experience. Everything has an interface that you need to interact with. And I guess on this point, actually, never mind. Let's go on. Make no assumptions. Otherwise, I'm just going to rant for another half an hour and not get on with my talk. So make no assumptions about your users. So we talked a little bit about you need to know your users. You need to know who the personas that you're working, building the solutions for are. But it's very important that you make no assumptions about how they interact with your system. And again, this is why we're bringing on other people from other teams so that we can all analyze the way that these users, these consumers are interacting with our stuff. And the same thing, like even if we go back to the equation example, like I don't think Einstein was worried about who was approaching it exactly, like who was going to use the equation. But I'm pretty sure he was concerned about who was going to read it and whether they were going to be able to understand what he was trying to explain. And that's another way to just make no assumptions about who's going to consume your information or even how you're preparing the information for them, right? You want it to be easy to consume. And the same thing applies here. Make no assumptions. You don't know the amount of knowledge that you have. You don't know what their background is. You don't know exactly how they're going to be using your software or the stuff that you're building. So it's extremely important that you not only collect requirements, but you also collect feedback so that you can iteratively improve the system and make it simpler. You should make fewer assumptions about the environment, and fewer is intended here. I think there are some assumptions that you can make about the environment. It's common to say that you should not make any assumptions about the environment, but that basically means that you will have to validate everything about the environment and the ecosystem where you're running from. And in this case, I am going to use software as a very specific example. So if you're running a service and you make no assumptions about the environment you're running on, then you're probably going to spend on probably half an hour of the boot time in pre-flight checks, validating that you have a file system, that you have network connectivity, that you have a bunch of other stuff that are already like a prerequisite for your software. So you can have a list of prerequisites and you can make some assumptions. Like another kind of like extreme example is if you're using any cloud service and you're using their storage service, you have to be failure tolerant for sure. But if you, granted that you have all the permissions, all the buckets exist, and that you can write to the storage itself, you can assume that you're not going to run out of space. Like if you run out of space on S3 or GCS, then we have a bigger problem in the entire world. And your software is not the only one that's going to go down. So there's some assumptions that you can make, but you have to be extremely clear on what assumptions you're making and why you're making them, so that those can be simplified away from whatever checks and whatever stuff that you're building, and you can focus on the other things that actually need to be validated and verified. Make it easier for the users to decide. And this relates to the very first part of the presentation where I was telling you, abstracting the complexity, again, it's not hiding everything away. If there's something that makes me extremely mad, it's like, because, okay, so I consider myself like an advanced user for most of the things. So if there's a thing that makes me extremely mad, is when tools that are simplifying more complex problems or like very annoying things to interact with hide everything behind a single button. And then your only interface is that single button that will do everything for you automatically. As an advanced user, you many times want to interact with some other parts of the system. You want to have the option to decide whether you want to go in advanced mode or you want to stay with the utterly simplified version and interaction way. So in some cases, it might actually make sense. But the most important thing here is that you have to, based on your user base, based on the way that your users are going to be interacting with the things that you're building, you have to make sure that you're giving them the option to decide which way they want to go and what they need to do. And with anything in life, there's always trade-offs. There's no way to go through all these without trade-offs. So again, if you're overly simplifying and you put in everything behind a single button, your big trade-off is that you're completely hiding all the potential of the things that, of the problem space that you're solving the problem for. But the most important thing about trade-offs is not the fact that they exist and the fact that you have to deal with them. It's the fact that you need to know them. And the only way that you can know what your trade-offs are is by completely understanding the complexity of the problem that you're solving. If you completely understand the problem and you make decisions based on, you know, all the information that you gather, then you're going to know what your trade-offs are. And then you have to go and document them properly so that you can give your users the option to decide exactly what they need to do. And I think all of these, what really is a case in favor for comfort zones, really. And I do want to spend some time here. We tend to push ourselves a lot out of our comfort zone. And when you tackle a new complex problem, you're pushing yourself into something that might make you uncomfortable. Like you're trying to solve this problem and make it easier for people to use. It gets you out of your comfort zone, especially because you're not only tackling something that, you know, it may be exciting for you, but you're tackling something that you're not, maybe not an expert on. It's a hard problem. You need to solve it. You need to spend money or time or whatever you want to say. And you're also building a solution that is not necessarily going to be perfect for the users that you're, or the people that you are targeting, and you'll have to accept that, right? You'll have to iterate, you'll have to make it simpler and simpler every time. But the case here for comfort zones is that what you're really after is creating a comfort zone for those people, right? You want to make them feel comfortable. You want to make them feel cozy in whatever solution you're building so that they will never leave. Going back to the doctor example, you want the doctor to feel comfortable with the tools that he or she are using so that they will stay, they will keep using them, they will keep providing you feedback so that you keep improving your software. So there's nothing, like, comfort zones are not necessarily entirely bad. Like we talk about them as something that we should always avoid as much as possible. But the truth is that it is good to have a comfort zone for many things in life, and there are some other things that you do want to push yourself you know, out of the comfort zone for. All right. How far should we take it? This is a tricky question. And again, it really depends a lot on your target audience and the problem that you're trying to solve. But all right, so it would be irresponsible of me standing here showing you the Einstein's equation and not quoting him. So I decided I was going to put one other quote from Einstein. And this is probably one of the few quotes that can actually be attributed to him, unlike the other 1,000 quotes online that don't make any sense. So Einstein once said that everything should be made as simple as possible, but not simpler. And it's a tricky thing to analyze, and I'm not going to stand here telling you that I understand exactly where he was coming from. That would be irresponsible of me. Also a massive lie. But he did that. He said that related. Sorry. He said that related to a lot of his work and a lot of the questions that he spent a lot of time simplifying, and a lot of the problems that he spent a lot of time explaining and defining and making available to people. And the important thing here is that we need to simplify things as much as possible, but we need to make sure that we're not dumping down all the stuff that we're working on. Like, you don't want to make it feel like, allow me to say, stupid for other people to approach the problem, really. There are some problems that are just complex. And again, like what we're trying here, like what we're after is to make them more approachable to people. So how far should you take it? It really depends on the problem space that you're solving and the things that you're working on. And I guess the next thing is like, okay, so we don't really know how far we should take it, but how do we know if it is simple enough? And once again, like, this is a hard question that honestly, I don't think I have a perfect answer for, but the best thing that I can do is give it to you as a mental model as well, as something that you need to keep iterating on every time that you're working on something, and keep asking yourself whether something is simple enough or not. And the most important thing to remember here is that I don't think you will ever know if something is simple enough. What you can know is what people will tell you once they start interacting with the things that you're working on, right? Which takes me to something that Gilles Deleuze said once, or wrote in one of his books, and probably is one of my favorite quotes from him, and is that technology is social before it is technical. And this basically means, like, he said it in a different context, to be honest. It was more related to having communities. It was more related to sharing software. It was more related to other things that he was interested in. But I think it applies perfectly on the topic that we're on right now, which basically means that you don't really ever know whether your software and the things that you're building are simple enough for other people to use until you actually have them use it. Right? So what you really want is to go to market as fast as possible, get it out of the door, and have people consuming the things that you built, and then collecting feedback and iterating over and over and over and over again until you make something that is comfortable enough for people to stay and to keep doing the, working with you on that cycle and giving you as much feedback as possible. And as a very last slide, and surprisingly enough, we are actually going to have time for questions later. I'm going to leave you with this, which is, of all the things, is what actually triggered me into diving more into this topic. And I did warn you that I was no exception for people, the 8 other billion people in the world that did sourdough during COVID. I did sourdough. I have my own sourdough. I do bake bread now. But one of those days, during one of the bakes, I was measuring the flour as you would normally do when you're baking breads. And it hit me that I was spending, because science and we're engineers and we would like to be precise, and okay, this is another way to say that I have a massive OCD. You want things to be precise. So you're there and you're measuring your flour. And you just like, you want like 350 grams of flour. And it hit me that as Europeans, we're really proud of our metric system, I'm going to say our, although it's not really ours, but it's really ours, metric system, and we like the way that we measure things. We like it because it's precise. We like it because it's repeatable. And we tend to rant about other measuring systems, and yes, I'm talking about the US, and how imprecise they are, how difficult it is to replicate if you're all not talking about the same language. But there's one thing that you have to grant to other volumetric, let's say, measuring methods, and is the speed and simplicity that they provide you with. And to make it more clear, I'll tell you that scooping 2 cups of flour out of a bag is always going to be faster and easier than measuring 350 grams of flour. I am not saying the volumetric measurement method is better than the metric one, but that is something that the metric system is never going to beat. And that is part of, I think that's a good example of what having trade-offs means, what your priorities are, whether it is simplicity, speed, or repeatability and reproducibility. And and what a good API or like, let's say API or like way of interaction with your users is. So I'm just gonna leave you with that. Think about it. Use it as a way to reason about your problems and navigate the complexity of the things that you're working on. And I just have to thank you for being here.
So we have a question, and it's, can you give us a concrete example in which you successfully obtained simplicity from a complex project?
Next question.
There are none.
Sorry about that. Just kidding. No, so, that's a difficult one. It's difficult because you never know if you actually build something that is extremely simple enough. But I guess the most valid example that I have right now is what we're doing in the new company that I joined. I joined as a platform engineer at this point, and we're building, one of our main goals at the company at this point is allowing people to self-serve their own infrastructure, right? And we wanted to make it super simple for them to create their own clusters, have their own databases and everything through code in a way that is repeatable. And especially we wanted to avoid them to be clicking on the Google Cloud interface because it's just untrackable and crazy bananas. I'm glad to say that I think we're succeeding on it. I don't think it is simple enough, considering that Terraform is not widely known at the company yet. But the process itself is simple enough. It's basically, for now, hopefully it's going to be simplified a little bit more later based on the feedback. But for now, you basically go, copy a directory, change a few parameters, commit the code, and then magic happens. So I think that's my current best example, honestly. I don't know if that is exciting to you people, but it is for me. It's paying my salary.
That's it.
That's
Thank
it.
you so much
Cool.
for the talk, Flavio.
Yeah, my pleasure. Oddio.
Our next speaker is Mattia Ferrini, and he will talk about decision science. If you have any questions, please ask them in the Slido, and they will be answered at the end of the talk. Thank you.
Hi, good afternoon. Thank you all for joining for the talk. The topic of the talk is decision science. So, what is decision science? Decision science is about making better decisions. And decision science is a set of methodologies and tools that combines forecast and estimates with operations research, game theory, behavioral sciences, and probably a lot more disciplines. I believe a lot of you have seen this journey that takes data through descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. And the classical data science takes you only down to predictive analytics, but then there's still a missing piece that needs you to take what has been estimated, maybe with some econometrics, maybe with machine learning, and make a decision with it. I'm very happy you're here. Maybe I don't have to sell you these too hard already, but decision science is becoming to matter more and more. The reason is that with better decisions, companies gain a competitive advantage. And with better decisions, you gain personal success. So it's wise to make good decisions. With better decisions, companies can translate data, their investments, into money. And I see that as a natural evolution of a data professional that started from being somebody who just produce dashboards that are going to be looked at and analyzed by others, to be a data scientist that helps with forecast, to become ultimately the decision scientist that makes decisions or supports executives in the decision-making process. And it's also a hot topic because, well, a lot of people still have not been using decision science. And I spent some time calling companies, executives, asking them, how are you doing your decisions? And pretty much most of them just said, well, it's my gut feeling. I get the forecast, I get some input, but it's my intuition. And that's suboptimal. Now, making good decisions is very hard. Why? Well, in the picture here, we have Professor Paul Frampton. He's a world-renowned physicist. He fell in love with a swimwear model. They had been chatting some time together until she persuaded him to help her out by going to Bolivia, grabbing a suitcase, and, well, somehow he got convinced. He went there, got the luggage, went to the airport, where it turns out it was full of cocaine. And the guy spent quite some time in jail. I mean, a super smart person. But the problem really is, I mean, it's a little bit of a dramatic example, but the point is that a lot of our focus has been spent on identifying biases in the data. There's a lot of research, high quality. It's been a very valuable exercise. But even if there were no biases in the data, the decision-making process could be itself biased. And this is something that is overlooked. And this is something that decision science aims to tackle. Well, point is that before making a decision, we have yet to make another decision. We have to decide what the decision-making process will be, which options will be considered, which information will be taken into account, whether I'm going to listen or not to friends saying that just grabbing a suitcase in Bolivia is wise or not. Well, there are a lot of biases here. You also might decide how much time you want to spend making a decision. So decision science is a set of tools that aims at creating a systematic process that is going to help you make better decisions. Everything starts with understanding the context of a decision. Point is, you're chased by a lion or a panther. Well, you don't want to start researching on your smartphone about the lions and panthers, right? Better run or scream or get some help. So you need to understand the context. Is it an important decision? How much time I want to invest? Is it worth to write a mathematical model or just running? The second step is about brainstorming on options and scenarios. And there's a wide body of research that says that you get tunnel vision. Oh yeah, that's how I'm going to solve the problem. It's better to step back, get a piece of paper, and write down options, scenarios. Making decisions is a creative exercise. So spend time on evaluating all the possible options that you might have. The third step, it's really, really tricky. It's where sort of like things start to get a little bit more complex. And it's about really understanding what optimal means, what is best for you, how you're going to measure the optimality, what the criteria will be, and also define all the constraints. Just a little example from everyday life. Is your GPS doing the right thing for you? Well, let's imagine that you want to go by car from one city to the other. Do you want to minimize travel time? Or do you want to minimize travel distance, something a little bit more environmental friendly? Maybe also adding a constraint that say, yeah, okay, I'm okay by trading off some time for something which is more environmentally cautious, but I don't want my trip to be longer than 3 hours, 4 hours, whatever. So it's really tricky, and sometimes you have already something where, well, some criteria, some approaches are deeply engraved. You're already made unconsciously sort of decisions that, well, about the criteria of optimality, and you're not even realizing these. I work on a route scheduling project where we helped a client having tons of vans, with technicians going around Switzerland and Germany to provide technical support at client sites. And for them, it was just obvious. I want to minimize the time spent in the van driving. But actually, that's not really what they should be aiming for. They should minimize idle time, or the time actually that they are not spending doing useful work. I mean, obviously there's a strong correlation there, but that little tweak can lead to a competitive advantage that can crush competition. Some games are really tough. And sometimes we don't even know really how algorithms work, how as a tool defined what is optimal for me. I read a lot about Tinder, for example, online. Well, how is Tinder deciding that that's a good match? Is that aligned with what I'm looking for? A lot of products have made a certain optimization decision for us around the criteria without sort of like transparently communicating that, and this is also a problem. Now, the good thing is that once you have defined what is optimal and defined the constraints, then Python comes at hand, and there are a lot of libraries that allow you to fluently formalize your problem with code at a very good level of abstraction. And those libraries tap into solvers. such as Cplex, Gurobi, Mosaic, and it's really important to be able to keep the definition of a problem at an abstract level, as fluent as possible, as close to the mathematics and formula as possible, and decouple the problem definition from the solution of the problem, which is often done better by solvers than what you would implement in a reasonable amount of time. And if we look at these, just a little example, let's assume that we have a company called Coolco. They produce cool products. Sorry, I haven't been really creative despite the pie drinks yesterday with names. But the point is that this company is having some analysts preparing with Excel the weekly schedules. I have lighted Excel because very often this is what is used by companies, and very often is a keyword that sort of like already signals that there's probably a room to improve. And schedules are often something where, well, people complain about. And it's really important. And when we were talking about context, it's probably something where, well, we can invest some time into some work. And this is how the code could look like. And we see that with something like Pyomo, things are quite natural. I mean, you define, you create your model, and then you define the decision variable, which is a tensor. Zeros means that, well, somebody is not assigned to a specific shift. 1 means that somebody is assigned to a specific shift. You can define your shift, how many days in the week the operations are supposed to run. This company runs the whole week. They have 3 shifts, morning, evening, and night, and it's natural. It's nice, and you can also continue working on that, and it really looks like Python. Then we see here that we're going to have to make certain assumptions about parameters, such as how many units a worker is able to build or produce per shift, what are the costs. If we make some assumptions also around the demand, the data scientist has calculated it with some machine learning. Okay, let's trust the numbers that we got from the data scientist. And then with that, we can define some business logic that calculates some definition of operating profit, how much you're able to sell with what you produce, and how much it costed you. And the same applies to the constraints. We see here a few examples. So you don't want workers to work more than a certain number of shifts per week. You want to be fair, so you don't want to have somebody staying at home unless he's on holidays, obviously. You don't want to be workers to have too many night shifts, one after the other. That would not be fair, right? And this is obviously like a big discussion with HR regarding regulation, etc. So everything looks nice. The key assumption, or the sort of like underlying building block of these, is that we get some values, some point estimates for your parameters, right? Like how many units a worker is able to produce per shift. And this is where probably the next step comes in. And for that, I have prepared another example, a personal example. Spoiler alert, there's no drug smuggling involved here, at least. Not that I know of. But the idea is that let's assume that you want to travel with family from Zurich, where I'm currently based, to Florence. And you have to decide whether you're going to go by train or by car. The forecasting, make prediction, and then decide approach would be you go on Google Maps, and you just check how much time it's going to take. But this is not how we work. We need to take into account scenarios. And this is where I was sort of like why I was mentioning before, it's a creative exercise. You need to think, what is the risk of delays? What happens if you miss connections? You're grounded in Milan with family, young kids. You have strikes. Then you have also to consider if you go by car, drive times, the possibility of getting jam, whether your daughter can feel car sick or not. So there's a lot going on here. And this is really where we have, you have this approach where you have to sort of like design scenarios, make assumptions, see what happens, stress test ideas. And this approach, by the way, is called agree on assumptions. It's still not really widespread, but really interesting to look at. And this is also something that can be done by Python. Another example is, for instance, let's assume that you have a company that runs cruises, and you have to define the optimal price and how many ships they should deploy ahead of the holiday season. So you can have a model where you take some historical data, and you also take some external data that gauges the willingness of clients to purchase the service, to travel. And you build some model where you want to estimate the relationship between quantity, this external driver, and the price. Something that looks like this here, you see some chart of the pictures, some estimations in terms of sensitivity between price and quantity. And then you want to maximize the profit, again, revenues minus cost, and find these, the optimal combination of price and number of ships. And let's assume that this model quantity is a function of this consumer confidence index that gauges the willingness to purchase a service and the price. Well, and you can have, let's assume it's just a linear regression, for instance. And you see that you can have uncertainty in a lot of places. You can be uncertain about the consumer confidence index. Also, the quantity produced by the workers might not be just 10 units. You might have a range. You might be also uncertain about the parameters of a regression that define the relationship between, for instance, the consumer confidence index and the quantity. And then you're going to get also an estimate in terms of quantity itself. And this is where I like tools like probabilistic programming, because allow you to naturally define things as probability distributions and then code and build business logic as if it was regular Python. Now, unfortunately, this is not a workshop. I'm not going to go through this, but you see that the magic happens here, where you define something as, well, a normally distributed, but it very likely is not going to be something normally distributed, but for the sake of simplification. And once you start having things that are probability distributions, there's a lot more that you can do in terms of, for instance, you can decide to optimize by taking the expected value, so the most likely outcome, and finding the combination of number of ships deployed and price that maximizes that. Or you might be thinking about other definition of optimality. For example, you might implement what is called the utility function. The fact is that at the margin, additional gains, when they become more risky, they become less interesting. Depending on your salary, but it's okay to buy Scratchy. Are you willing to risk 10,000 euros on 100,000 euros on a bet? This is where utility comes into play. And so you can define also definitions of optimality that take into account some definition of risk. For example, you can look at where things are if you look at the lower quantile and you don't look at the expected value. But the point is you have a lot more information, and you can tune your definition of optimality according to that. Taking a bird's eye perspective on that, we see that Python offers the complete framework to tackle this kind of problems, including the probabilistic programming piece, but also connectors to different solvers. Here we sort of like looked at standard mathematical solvers, but you might also problems that require meta-heuristics or reinforcement learning. Python is a Swiss Army knife. Now, I see that I'm not doing too bad in time. So we have the time also to discuss, strangely enough, and we have also time to discuss the last piece, which is about evaluating the decision. And this is extremely hard because a good decision is not something based on the outcome. I mean, you might play a gamble, you win the gamble, and you might think, well, that was a good decision. No, you were lucky. A good decision is having assessed the risk and benefits associated to the gamble correctly. And this requires a lot of discipline because you have to keep in mind that now you know more than the moment you made the decision. You have to forget about the outcome, and you have to put aside also the feelings. You lose a gamble, you're extremely disappointed, it's very subjective, but evaluating the decision is really tricky. You also might want also to compare decision models. So you might also want to build experiments, A/B test, and it's a whole field in a field. And this is also what makes, coming to the conclusion, decision science cool. I mean, I only scratched the surface. This morning I realized that I had probably 1.5 hours of content for this talk. I'm not sure that the colleagues that coordinate would have been happy with that, but I didn't even touch upon game theory and the fact that somehow often decisions, the best decisions are suboptimal. Think about, for example, how ice cream parlors put themselves on a beach, right? Ideally, they should be equally spaced so that those at the beach have to walk the least to get to the ice cream parlor. But somehow, they all end up in a center. And this is because there's this game theoretical story where somebody comes in the morning and he wants to grab the space, so he puts himself in the middle, right in the middle. And another one comes maybe 5 minutes late, and does he want to be cornered at the edge of the beach? No, he also puts himself in the middle, 30 centimeters, 2 meters away from me. So decision science is cool. I think it's interest on this discipline is growing, and that's all I have. All I had to say. 24 minutes or 30 seconds. Thank you.
That's great. So we have a couple of questions. The first one is, what if the target function is unknown? Does exist some structured approach to try to find it out? A/B test, experiment, design, etc.
Well, I guess this is where the human component comes into play. And believe it or not, I work in a consultant. By the way, I also forgot to mention that if you are interested in these topics and you would like to connect, we're also hiring, so I'm going to be like hanging around here. But by the way, this was the 20 seconds that I saved from the presentation. But the point is, what you really need to do is to sit down with those the key stakeholders, or with yourself and your wife, whether this is a personal decisions, and try to get to the point. And it can be extremely complex because, well, you have to understand, on one hand, that probably your decision is going to be something tactical, where tactical is price setting, defining quantities, deciding how many ships should be deployed. This is something tactical. But everything you do tactically has always a strategic long-term impact, and this is extremely difficult. And then, as the speaker earlier on was saying, there are a lot of trade-offs, and you have to decide what's important for you and how much weight you want to put on every factor. You can have a setup where you decide to trade off some financial profit for a more ambitious achievement of sustainability goals. But where's the trade-off? will the shareholders of your company be happy? So there's a lot of work, and believe it or not, is very often probably 90–95% of the project.
Okay, thank you. Another question is, how do you handle discussions with experts when proposing an optimization over stochastic variables? Errors are tough to explain.
I need to think if I interpret the question correctly. And I think this question relates to the fact that people and companies are used to point estimates. I remember one of my very first bosses when I started working a few years ago, not many, was coming to me and saying, give me the number. So there's no culture of uncertainty, there's no culture of ranges, and this is really, really hard to overcome. And I guess this is where the question comes in. I think there's a process where you sort of like try to sit down with the decision maker and explain that if you put 100% certainty on a point estimate, that you might be over-optimizing for that very specific outcome. Whereas what you want to do is find a solution which is robust across all the spectrum of scenarios and across all the spectrum of uncertainty and variability around your forecast. Hopefully I interpreted the question correctly.
I think so. That's great. Another question is, which resources would you recommend to learn more about decision science in general?
It's very hard to find a very, very targeted source because first off, this is somehow a place where different disciplines sort of like unite and get together. So probably what I'm going to also try to do is I would like at some point in time to put together an introductory reading list, collecting some publicly and freely available documents. So probably the answer is maybe connect with me online, and at some point in time, I'm going to be publishing that list. I think it's actually this is a frequently asked question, and I should tackle that at some point in time.
Great. Another question is, how would you introduce decision science in a company that doesn't use it yet? For context, the one who asked this says he's not the one who makes the decision.
Yeah. Fear of missing out. Fear of missing out, that's the most powerful tool you have. There are companies that are already driving the topic. Google has his first chief decision officer since a few years. The military, the US Army introduced chief decision officer. So it's sort of like the strongest message I found that works is really leveraging the fear of missing out and saying, look what your competitors are already doing. Look what other companies are already doing. And then what you need to do is to figure out a good use case, which is not too complex, where you're going to just play with decision sciences and show them, okay, this is the value that we brought to the table by introducing decision sciences.
Great. That's all the time we have. So thank you so much.
Thank you all. Thanks.
serve. Sì, sì.
Diciamo che con la ripresa.
Sì, 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 ho già...
Che c'è un fischio che ci arriva dalla
sì, sì, mi serve solo questo qua. Sì. Sì. Cioè... Ok, cioè devo fare qualcos'altro?
No, lascerà la slide. Che almeno testano di là. La registrazione del stream.
Ok.
So our next talk is by Andrea Guarino, and he will talk about code quality and how to write clean code in legacy projects. Thank you. Also, if you have any questions, please ask them on Slido. Thank you so much.
Okay, hello everyone. Thank you for coming to my presentation today. So today we're going to talk about clean code and code quality. And I promise you that if you're going to follow this presentation, so you're going to learn how to write clean code even on legacy projects. But first, let me introduce myself. So I'm Andrea Guarina. I'm a software developer, and I work in a company called Sonar. And at Sonar, we want to help developers to write clean code. And myself, I'm one of the maintainers of the static analyzer for Python language. So let's see what we're going to see today. So we're going to start by seeing together what are some problems and challenges that we deal with code quality tools, especially when we add them on legacy projects. And in the second part of the presentation, I'm going to show you a few techniques to how to deal with those challenges, and we're gonna shift the focus on new code. So I'm gonna define a bit better what I mean by new code here, and we're gonna see together a few techniques to help you put the focus on new code. Okay, but first let me ask you. So are you familiar with this kind of tools? So those are linters that you might find in your IDE. So can you raise your hand if you use that? Okay, that's pretty good. So today we're going to talk about static analysis, about clean code, and but first let me define a bit what is static analysis. So static analysis is a technique that we use to actually analyze code without executing it, to say it really in a nutshell. And that it's useful because it helps developers to write clean code. And clean code here, I mean code that is maintainable, so that it's easy to read and to maintain by yourself and by your colleagues. And also, we want code to be correct. So we don't want to have any bugs in our code. And also, we want our code to be secure, because this is also about security. So we don't want to have any vulnerabilities in our code. And why static analysis is useful? Well, maybe if you have to do a code review of this code snippet, maybe with the manual review, it's not so easy to spot that in this code there is actually a problem. And here, so if you look carefully, so at line 203, so you see that the developer is using the extend API of list to actually modify the list. But probably in this case, the developer forgot that the extend API returns none because it's modified the list in place. So it means that the option key is gonna be none, and probably at some point it's gonna explode in an attribute error. So that may be quite dangerous. So today for my presentation, I'm gonna use as an example project. I'm gonna use FluxBB. First, because it's a project that I really like. It's pretty popular. It has also a good size. It's 20K lines of code, and probably you already encounter online this software because it's often used to write forum online. And let's say that we want to add code quality, so a code quality tool to FluxBB, and for that purpose, so we're gonna use PyLint. So PyLint is one of the main popular tool for static analysis and for linting of Python code. And in this case, so let's suppose that we want to add that in our CI. And in this case, so we're going to use GitHub Action. So here we have a lot of boilerplate, but the most important thing is only this last line. So that is about just to run PyLint on FluxBB. So as simple as that. So let's suppose that we put that in place in the CI. And so after we do the first analysis, so we're going to see this. So we're going to be overwhelmed by messages and you see that even well-maintained project like FluxBB has a lot of messages, a lot of issues to deal with that are related to maybe refactoring, suggestions, to I don't know, conventions that are not respected, and so on. So how to deal with that? And in this case, so we have 1,800 messages. And just as a reminder, the size of FlashBB was 20K lines of code. So it's pretty high ratio anyway to deal with. And so here you see in this slide recap of the messages that we saw in the previous slide. So you see that we have 800 conventions that are not respected, refactoring suggestion, a lot of warning and errors. So let's see a few challenges of what I call here the traditional approach to code quality. So the first thing is that, okay, let's suppose that you are the maintainer of this legacy project. And so maybe you see all those messages. So the first question that you might ask yourself is, okay, but where do I find budget? Because maybe I will have to spend I don't know, days, weeks, or even months to go there and fix all those existing issues. Then the second problem that I see here is the risk of functional regression, because so let's suppose this is a legacy application, so that it's been in production for since a few years maybe. And so maybe there are indeed some problems, some bugs that happen in production. However, if in your company maybe you have a support team, maybe they already know how to deal with existing problems. So they know how to deal with customers and so on. So if you go there and actually modify the old code, I think you have a quite high risk of functional regression. So you have to be careful to actually do that. And lastly, so a problem that I see is also what I call here the developer pushback, in the sense that maybe you're a new maintainer on this project, so it's not code that you write yourself, and so maybe you might have pushback because maybe even the people that wrote this code maybe left already the company, so you don't have anyone to ask if you don't understand the code. And so I think at the end it might be even boring to go there and try to fix existing issues. So what happened with PyLint usually, so what I observed on some popular projects is that maintainers prefer to really limit PyLint at the bare minimum. So in this case, we see that we have only 4 rules that are enabled for PyLint. And of course, this can be, I mean, can help because then you have much less messages to take care of. However, I think it's not the ideal solution that we should strive for. And why is that? Because I think that static analysis and code quality are really powerful tools that we have in our daily job. And so by doing that, we are limiting a lot the power that comes from those tools. So I think that we should strive for something better. Also, so far I only talk about messages. However, we shouldn't forget that that code quality is not only about messages, but it's also about metrics on our code. And in this case, so I would like to highlight the unit test coverage. And you see that on FlashBB, they already track that they have 44% of code coverage. So it's already very good that actually they track that. However, let's say that at some point, we decide that we want to have 80% code coverage. So does that mean that we should spend days or even months to actually write more unit tests on the spot on old code? So probably we don't want to do that. So you see all those challenges, all those messages, the coverage that is not at the right level. So where do I start to actually introduce code quality in my project? So what I would like to present today is first, keep calm and focus on new code. But first, let me define a bit better what I mean by new code. So I think that the simplest definition of a new code can be thought as a new pull request or a new commit in your project. So in this case, it's really the smaller instance. However, we can extend the concept of a new code a bit further, and maybe if our team is working in an agile environment, maybe with some iteration like in sprint. So in this case, maybe we want to consider new code the period, the duration of the sprint itself. So maybe we might want to to focus on the current sprint and maybe put, I don't know, maybe 3 or 4 weeks duration to consider it as new code. And lastly, so if the project is implementing semantic versioning, so we might think also of considering new code, so the new code that were implemented since the latest release that we did. So if for example, we already released the 1.2, and we are working on, we are adding new features for the 2.0, so we might consider the code that goes from 1.2 until 2.0 to be actually new code. So for the purpose of this presentation, so I'm gonna use the simplest of the definitions, so it's just pull request. And in this case, so let's suppose that I want to add, for whatever reason, quicksort algorithm on FlashBB project. So I write my code. Of course, I write also my unit test to make sure that the code is correct and is working fine. And then again, so I have the CI activated. And again, I see this lot of messages that are thrown at me again. And in this case, so if you read very, very carefully, you can actually spot those 3 messages are related to the code that I just wrote, so to the quicksort algorithm that I just wrote. And you see that in this case, it's just, so it's a convention problem, so I forgot to put the docstring. Then there is a refactoring suggestion about unnecessary else, because there is already a return, so it's not really necessary. And lastly, it's about some variable name convention that I'm not respecting here. However, so you understand that if you want to do that for every pull request, so if you want to go there and dig in the log for every pull request, it's not something really scalable, because we have all those old messages that are there. And so I think we should strive to improve this situation. So how can we do that? So maybe the first approach that we might think of is, okay, let's only run PyLint on change files. So, and how to do that? So again, we have the GitHub action here with the boilerplate that we can ignore. And here, so maybe I might think to add PyLint on top of gitdiff. So gitdiff just tell us, in this case with the name only flag, it will tell us what are the names that are changed between the current branch and the main branch. And in this case, so we only run PyLint on those files. So let's see what will happen here. So you see that it's already much better. So here we only see the messages that are relevant to the FlashBB CLI utils. That is the method that the module that I modified to add the quicksort algorithm. And here again, so I have the 3 messages, the same 3 that you saw before. And this way it's already much easier to actually spot those 3 issues. However, to be completely fair, I'm still quite annoyed about those old messages that I see above, because they have nothing to do with the new code that I just wrote, right? And in this case, so the CLI utils module was pretty small. However, if you think that you have to maintain maybe a project with a very, very long file, and that happened, unfortunately, so we might end up in a situation that is more similar to what we saw before. So with a long list of messages that we have to deal with. So I think we should strive for something better. But first, let me formalize what I'm trying to do here. So here I'm introducing what I call the clean as you code methodology. So clean as you code methodology means that the quality of your code should be measured only on recent changes, so on new code. And again, so we want to focus on new code, but we would like to focus only on new lines of code that we just wrote, so not on new files. And again, here I will remember that this is not only about issues and messages, but we would like also to put the focus on the metrics. So I think that also metrics should be defined only on new code. And so if you remember here the recap slide for the entire messages that we saw before, so what I would like to have with the clean as you code methodology is to have only the 2 convention project that the 2 convention messages that we saw before, and the 1 refactoring suggestion. And then in this case, no warning and no error. And again, so you might remember that one challenges was about where to find budget. But hey, in this case, we are just implementing a new feature. So to actually go and fix those problems that are reported by the static analyzer tool is something that is really part of the job, right? So you don't need any dedicated budget for it. So it's not a problem anymore. About functional regression, well, to be fair, you always have a risk of functional regression, right? However, in this case, the scope will be much smaller, so because it's only on new code. And I think in this case, so the code quality tool can even help you to prevent some functional regression, because in this case, maybe there is something that you didn't think of. So I think it might be helpful in pair with the unit test that you're gonna write, of course. And lastly, about the developer pushback, I think it's not a problem anymore, because in this case, it's a code that we just wrote. So I think that we already have a sense of ownership on this code. So this is not a problem. And as a bonus point, I think you have also the opportunity to learn something new. And what I mean here is that maybe the code quality tool will tell us something about, I don't know, a new feature of the language that we are not aware of. And so I think it could be really a nice opportunity to actually read carefully what the static analyzer is telling us, because the scope it will be much smaller. And so we can actually understand what are the messages that PyLint is telling us here. So we saw together the first step. So as a reminder, was to only focus on the change files. However, with the clean as you code methodology, we would like to go a step further, so to only focus on the change lines. So how to do that? And I would like to introduce a tool that is called Darker. So have you heard of Darker before? Can you raise your hand if you did? OK, that's great. So Darker is a CLI tool that can be run on top of code quality tools, in this case of PyLint. And so again here, so if you remember the GitHub action, so in this case, I'm going to run Darker, and I'm going to instruct Darker to compute the difference between the main branch and the current branch. And in this case, so it's going to run PyLint on FLASBB again. So it's as simple as that. And so if we do that, so you see that the next time that we execute this, we're going to only see the 3 messages that are relevant to the quick sort algorithm that we just wrote. And I think this is really the fundamental step of the clean as you code, because here you have the focus put at the right level, so you're not bothered with old messages anymore. So as an alternative, I would like also to suggest Sonar. So Sonar is the company I work for, and at Sonar we actually put in our products the clean as you code. Really, it's a core feature of our product. And in this case, again, so Sonar has its own GitHub action that can be used. So in this case, we would have to produce a report for PyLint. So in this case, we're going to put everything in this PyLint report.txt. And then the Sonar Cloud, so it's the cloud version of Sonar, is going to be fed with this report. And so once we modify the continuous integration with that, so we're going to see actually that in the pull request, so here we are in a GitHub, so we're going to see this message from the Sonar Cloud bot, and you see that it's reporting us those 3 CodeSmell. So CodeSmell is the terminology that is used by Sonar to indicate messages of PyLint. And you see, so if we click on one of these links, so we're going to end up in the Sonar Cloud UI. So Sonar, it prefers to be more graphical interface in comparison to Darker, where it's more CLI-based tool. And in this case, so you might recognize that we see again directly in the code that we have the missing doc string, the unnecessary else, and the variable name x that doesn't respect the convention. And you see that we only see those 3 issues. So again, we have the focus at the right level. Also in Sonar, we have what we call the quality gate. So the quality gate is an indicator that tells you if if your code is production ready or not. And in this case, it's not production ready because we have those maintainability problem to deal with. And you see also that we have the coverage that is not at the right level. So in this case, we want to have coverage at 80%. However, in this case here, we have 75.9%. However, you might remember that the code coverage of FlashPB was at 44-something%. So you see that here we see a different number, and that's because the coverage is computed only on new code. And I think that this number is much more actionable because it's much easier than to write more unit tests to make sure that it actually fills up the 80% that we need. And here you also get an estimation of what's gonna be the code coverage once we merge this pull request on the main branch. And I think this helps you to deal incrementally with improve the code coverage. And here you might spot that we have also this one bug that is under the reliability section. And why is that? Is because Sonar has also its own static analyzer for Python. And in this case, it was able to find one bug here, is that I forgot to add the raise keyword on this exception. And so it means that if the array is going to be none, then at some point it's gonna blow up. And so we're going to have an attribute error again. So you might remember that the title of this presentation is to forget about the old code. However, that was kind of a lie, because so you know that when we have to add new feature, we anyway have the opportunity to modify existing code. And while we do that, so if we put in place the quality gate, so it means that the new code that we're gonna write, so even the one that modified the old code has to respect the code quality standard. And so here, if we just do an assumption that maybe after 1 year, we had to touch 20% of the existing code base, it means that 20% of the existing code base is gonna be clean. And here, if we project this to 5 years, maybe we're gonna touch the 50% of the existing code base, and it means that half of the code base is gonna be clean incrementally. So if you think that I made up this number, so you might be right. However, so you might be interested to actually see this article from Eric Byrne. So he actually built a tool to actually understand what is the percentage of commit that is going to be modified or that is still present in a code bases. And you see here, for example, we have a few popular projects, and we see Django in this case. And you see that on Django project, after 5 years, so 0.5% of the commit are not there anymore. So it means that they had to be refactored somehow. And that means that could have been an opportunity to actually clean the code incrementally. So to wrap it up, so we saw together a few challenges with dealing with code quality tool, especially on old code, on legacy projects. And we saw together a few techniques that were based on the clean as you code methodology. The first technique we saw was based just simply by using the git diff. The second, more advanced technique was based on tools like Darker or Sonar that really that compute the diff only to show you the issues on change lines. And finally, we also see a way to deal with the code base, even the old code base, and to clean up incrementally this old code. So that's all what I wanted to say. So if you have questions, I'm happy to answer.
We have a few questions from Slido. First one is, what's the difference between PyLint and PyLance?
So to be honest, I don't remember. I think that PyLance is the tool from Microsoft, if I'm not wrong. So I think it's just they are two different code quality tools. So probably each has its own strength. And but yeah, I don't know precisely what is the difference between those two.
Okay, thanks. And do you define clean code only in terms of static analysis?
Well, I think it depends. I wouldn't say so. I think that clean code can be defined also in larger terms. And for example, I don't know, you might think that the number of unit tests that you have or any other metrics that might be relevant to your code can also part of the definition of clean code. However, for the focus of this presentation, it was mainly based on static analysis.
Thank you. Another question is, what's your favorite stack of linters, formatting tools, and so on for Python projects?
Stack of linters.
Sorry?
So the stack of linters for Python project?
Yeah.
Okay, that's an interesting question. So I might be a bit biased because I work for Sonar, so I think Sonar is really useful stack to have in mind. Then I think also I would recommend tools like Black to deal with styling. So I think this is also very useful. And I think also FLAC 8 is a really useful tool that also deal this with good messages and not too many false positives.
Thank you. At the moment, we don't have any more questions on Slido, but if there's anyone who wants to ask a question, I'm happy to reach out.
Can we set the local linter in the code editor to start looking only from a day, only from that day to the new code?
Yeah, I think that's gonna be possible, and that would fall, let's say, in the second definition, more or less. So you can actually say from what day you want to let's say to track clean code, and so that's also possible. Then I think it depends also on the tool that you're gonna use. So I'm more familiar with Sonar tool, and I know that in Sonar you can define the exact date from which you want to start to consider new code.
Sorry, it's a bit random, but do you see those generative models playing a huge role in the future in terms of static analysis of code, or not really?
That's an interesting question. So I think they might be useful, and they already are proving to be useful. However, yeah, I'm really excited about what they can bring to it. So yes, I think it will be eventually, but let's see.
We have another question from Slido, and it's: do you use pre-commit?
Sorry?
Do you use pre-commit?
Pre-commit. So I think that pre-commit might be useful. Me personally, I don't use it, so I prefer to rely more on the CI check, and also to rely, let's say, on the ID. So if I talk about Sonar, for example, Sonar has also the correspondent product that it's Sonar Lint that is going to run on the ID, and that's something that could help you to be synchronized, so to also see the same issues on the IDE, the same issue that you would see reporting than on the CI. However, I think that for team is more useful to actually have a more centralized approach, so to have the continuous integration in place, because yeah, otherwise to put the pre-commit on each developer maybe might be a bit more complicated.
Thank you. And we have time for one last question.
Sorry, just curious. Do you also do static type checking? MyPy, for example, and
yeah, we do. Yeah, actually, we do also type checking. We have a different, let's say, objective than MyPy, because in our case, we want to report cases that might produce bugs or, let's say, maintainability problems, while maybe MyPy wants to go a bit further. And also, we don't enforce developers to have type hints, so we try to do type inference ourselves, so to actually guess what the right type is.
Great. We don't have time left, so thank you so much, Andrea.
Thank you.
And now there's coffee break.